The sun rises over the Giza plateau as it has for more than 4,000 years, pouring light across three colossal silhouettes that command the horizon. The Great Pyramid of Khufu, flanked by those of Khafra and Menkaure, still dominates the desert skyline like a riddle written in stone. The wind carries fine grains of sand around their massive bases, whispering over blocks that weigh as much as entire cars, each placed with precision so exact that modern engineers still struggle to replicate it. These are not ruins. They are living monuments to an age that defined endurance, geometry, and mystery in one impossible structure. From the moment travelers from Greece first described them to the modern era of high-resolution drones and cosmic imaging, the pyramids have been an obsession. Every generation rediscovers them and asks the same question in a new language. Who built them and why? Behind that question lies an even deeper one. How could a civilization more than 40 centuries old produce a structure that not only survives, but remains mathematically aligned with true north to within a fraction of a single degree? The alignment is so exact that some have called it the world's oldest observatory, a map of the heavens frozen in limestone. Archaeologists have traced the builders not to lost civilizations or vanished gods, but to thousands of workers, artisans and engineers under the reign of Pharaoh Khufu around the year 2570 before the Common Era. Excavations at nearby worker villages show bread ovens, copper tool remnants, and even bureaucratic graffiti listing work gangs by names like the Drunkards of Menkaure. This is not fantasy, it is organization on an imperial scale. Yet, even with this evidence, the central puzzle remains unsolved. How were more than 2 million limestone and granite blocks, some weighing up to 80 tons, lifted and placed with precision that rivals laser measurement? What purpose demanded such effort? A tomb, a symbol of divine ascent, or something even more elaborate? The deeper one studies, the more contradictions appear. Traditional theories of straight ramps or circular spirals require more material and labor than the pyramid itself. Others propose internal ramps hidden within the body of the structure, or counterweights operated with water pressure. None of these answers are complete, and that incompleteness keeps the mystery alive. For every solved question, two more arise, like echoes returning from the silent chambers inside. Modern Egyptology teaches caution. Evidence must come from excavation, not imagination. Yet even the most careful archaeologists now look to physics to see what chisels and brushes cannot. The pyramids are sealed histories, and their secrets lie behind millions of tons of stone. To look inside without breaking them open demands new eyes. Over the last decade, scientists have turned to cosmic rays, infrared imaging, and computational modeling, tools that let them read density, temperature, and voids hidden deep within the limestone heart. These technologies mark a turning point. They can reveal spaces untouched since the pyramid was sealed. For the first time, humanity can peer into the internal anatomy of one of the largest structures ever built without removing a single stone. The promise is staggering. What if there are chambers that have never seen air since the Old Kingdom? What if some internal design was intended not only for weight distribution, but for some deeper function, mechanical or symbolic? The discovery of hidden spaces could reshape more than archaeology. It might rewrite our understanding of how ancient Egyptians perceived energy, motion, and immortality. To them, power was not electrical, but cosmic. The pyramid's shape itself was a ladder for the pharaoh's soul, a geometric conduit pointing to the circumpolar stars, those that never set. Within that geometry might be clues to how they viewed matter, vibration, and stability. Every block, every angle was part of a vast equation of faith and physics. It is tempting to imagine that we already understand the pyramids, that they are mere relics catalogued and explained, but each new scan proves otherwise. Beneath the familiar surface lies a labyrinth of unknowns, empty spaces where no spaces should exist, temperature variations that defy uniform stone, patterns of density that hint at chambers or tunnels yet unseen. The pyramid is not a solid monument, it is a stone organism with veins and cavities whose purpose is only beginning to be mapped. The more we learn, the more the question changes. It is no longer simply who built the pyramids or how. it becomes why they engineered them with such impossible perfection. Why did they build in a way that defies erosion, time, and even understanding? Was it to honor gods, to immortalize a king, or to test the limits of human will? Archaeology meets cosmology at this frontier. To look inside a giant stone mountain, we must use tools born from the stars themselves. Cosmic particles known as muons fall through Earth every moment, traveling faster than bullets, capable of penetrating hundreds of meters of rock. They are fragments of distant explosions in space, and they allow scientists to image what lies beyond sight. With these tools, researchers are now doing what once belonged only to myth. They are seeing through stone, and so the story moves from sand and chisels to sensors and detectors, from speculation to measurable physics. To truly understand what powers the pyramids, we must first learn how to see them anew. The next chapter begins not with dust and light, but with cosmic rain and the strange invisible particles that carry the signature of the universe itself. The desert around Giza is silent now, but in ancient times it was alive with movement. Thousands of workers hauled stone blocks from quarries across the Nile, guiding them on wooden sledges greased with water to reduce friction. Teams of surveyors watch the horizon, aligning each course of stone with the cardinal directions using simple tools and extraordinary patience. Every line, every angle carried meaning. The pyramid was not only a tomb, it was a statement about order, the balance between heaven and earth, a symbol that the world itself had been set into geometry. Yet even in this grand order, there were mysteries. Ancient texts describe rituals for opening the way to the stars, for awakening the eternal body of the king. The pyramid was designed to survive eternity, but perhaps also to function in a way we do not yet understand. Scholars have debated whether it was meant to channel starlight, direct cosmic energy, or simply to ensure the king's rebirth in the afterlife. The truth may lie somewhere between science and symbolism, where the builders understood that structure itself could embody power. When the first explorers entered the Great Pyramid in recorded history, they found only narrow passages and empty chambers. The king's chamber, lined with granite from Aswan, held no treasures. The queen's chamber deeper within revealed no relics, only shafts leading upward, small square tunnels carved with precision, pointing toward the stars of Orion and the North Pole. Were these symbolic pathways for the soul, or technical components of a larger design? Each interpretation opens a different doorway into the past. The geometry of the pyramid is more than impressive, it is mathematical poetry. The ratio between its height and base approximates the value of pi, and the slope of its sides mirrors the relationship between the radius and circumference of a circle. These proportions are too exact to be coincidence, and they suggest that ancient Egyptian architects understood relationships between shapes that would not be formally defined until millennia later. Some physicists describe the pyramid as a resonance chamber, capable of focusing natural vibrations of the Earth itself. Though this idea remains speculative, the precision of the structure invites such comparisons. The Great Pyramid once shone white under the sun, its limestone casing stones polished to mirror the light across the desert. From miles away it would have appeared as a beacon, a mountain of radiance symbolizing the primeval mound from which creation began. The Egyptians called this place Akhet Khufu, the horizon of Khufu, a threshold between worlds. To the ancient mind, building such a monument was not an act of pride, but an act of cosmic balance. The pharaoh, as divine intermediary, maintained harmony between the heavens and the living world. The pyramid was his instrument. Still, the logistics remain staggering. Modern engineering calculations suggest that the pyramid's construction required placing one block every 2 to 3 minutes over 2 decades. This implies an organizational system beyond anything previously imagined for that era. Ramps, levers, pulleys, whatever methods were used, had to operate with near-industrial precision. Yet, no remains of massive ramps have been found. Only fragments of infrastructure near the base hint at temporary structures long erased by time. To solve such mysteries, scientists now combine archaeology with physics. Each stone of the pyramid is like a pixel in a vast three-dimensional image. Traditional excavation cannot touch most of it, but cosmic particles can. These subatomic visitors, muons created when cosmic rays strike Earth's atmosphere, pass through the pyramid, and scatter according to the density of the material they cross. By measuring this scattering, researchers can map internal structures with remarkable accuracy. This process is known as muography. Infrared imaging complements this, detecting subtle differences in surface temperature that reveal hidden voids or air pockets beneath the stone. Together, these methods transform the pyramid into a kind of scientific observatory, where physics reveals history. But the data raise as many questions as they answer. What appears as a void could be an empty chamber, a zone of lighter stone, or even an intentional structural feature. Decoding the pyramid has become a multidisciplinary challenge, requiring physicists, archaeologists, engineers, and computer scientists to collaborate like detectives solving a cosmic puzzle. Each new discovery shifts the conversation. In the past, explorers relied on chisels and torches. Today, we use particles from exploding stars. We can now see through the stone skin of the pyramid without disturbing it, tracing the invisible paths of cosmic radiation as it paints a picture of what lies within. The first results have been stunning. Hidden spaces, irregular densities, and cavities where none were expected. These findings hint that the pyramid may contain internal complexities far beyond our previous understanding. Still, interpretation is everything. A void is not necessarily a room, and a density shift does not always imply technology. It could mean architectural foresight, a deliberate manipulation of mass to prevent collapse. Yet, the fact that such precision exists continues to challenge our assumptions about ancient capability. The builders of Khufu's pyramid mastered geometry, logistics, and labor in ways that rival modern systems, all without iron tools or powered machinery. They understood weight, leverage, and material properties intuitively, guided by centuries of experimentation and observation. What remains constant through all theories is awe. The pyramid was built not by an alien intelligence or a forgotten super-civilization, but by people, tens of thousands of skilled humans organized under a vision so grand that it still dwarfs imagination. They worked by torchlight, hauling and aligning stone upon stone until mathematics became monument. The pyramid is both evidence and enigma, proof of humanity's reach and a question about its limits. As we stand before these monuments, what we truly face is a mirror of ourselves. Every generation projects its knowledge, its fears, its hope for understanding onto these ancient stones. The Greeks saw them as mystical temples. Medieval travelers believed they hid alchemical secrets. 19th century explorers called them treasure vaults. Now, 21st century scientists see them as data sets, scanning them with detectors and algorithms. Yet, the feeling is unchanged: wonder. And so, the eternal question remains open, luminous against the horizon. Who built the pyramids, and why? Each answer is provisional, each theory a fragment of a larger truth. To uncover that truth, we must look not only at the stones, but at the spaces between them, the silent voids that may hold the next revelation. And to do that, humanity now turns to the tools of the universe itself. The story continues with the physics of the invisible, with particles that pass through everything, yet reveal what was once hidden from every eye on Earth. Night settles over the Giza plateau, and the temperature falls sharply. The stones, which blazed under the sun only hours ago, now radiate the stored heat of the day into the cold desert air. It is in this balance of light and shadow that the pyramids seem most alive. Their faces vanish into darkness, yet their silhouettes remain impossibly clear against the stars. For ancient eyes, this was no coincidence. The pyramids were built in dialogue with the sky. Their sides mirror the angles of the rays that touch the earth at dawn and dusk. Their placement echoes the 3 stars of Orion's belt, and their orientation follows the slow rotation of the heavens. To build one was to anchor eternity to a single point on Earth, but alignment alone does not explain their power. Beneath the geometry lies intent. Every block was a vote of faith, every ramp an act of belief in the afterlife. To understand why the ancient Egyptians built these monuments, we must enter their worldview, a cosmos ordered by Mat, the principle of balance and harmony. In their eyes, creation was fragile, always at risk of returning to chaos. The pharaoh's duty was to uphold this balance, and the pyramid was the physical manifestation of that task. It was not simply a tomb, it was the axis around which the universe turned. In this sense, the pyramid was alive. It linked the material and the divine, the measurable and the eternal. When the pharaoh died, his body became still, but his soul was thought to rise through the pyramid's passages, guided by stars, toward an unending existence. The pyramid's shape, its perfect convergence toward a single point, embodied that ascent. Its smooth sides symbolized the rays of the sun, and at the summit, where all lines meet, the pharaoh would merge with the solar god Ra. This was not architecture for utility, it was architecture for immortality. Modern physics finds beauty in similar principles. Just as the Egyptians built monuments to preserve order, scientists seek equations that describe the balance of nature. Gravity, motion, light, each obeys laws of symmetry. The pyramid, in its form, reflects the same pursuit of underlying order. Whether carved from limestone or written in mathematics, the human impulse to find harmony between heaven and earth endures. Perhaps that is why these structures still speak to us. They are physical equations, solved not on paper, but in stone. And yet, despite millennia of study, the pyramids refuse to give up all their secrets. Beneath their calm exterior, they conceal internal geometries and unknown voids. The builders left no blueprints, no written record of the exact methods or purposes behind every chamber. We possess fragments, hieroglyphs, tools, tombs of workers, but not the whole design. Some researchers suspect that we have underestimated the scale of internal complexity, that what we call a pyramid may be only the visible layer of a far larger structure buried in sand and mathematics. Recent discoveries challenge our assumptions. Ground-penetrating radar has revealed tunnels beneath the plateau, possibly older than the pyramids themselves. Scans have detected thermal anomalies, as if certain stones retain heat differently, suggesting hidden cavities. These hints do not yet tell a coherent story, but they remind us that the Great Pyramid is not a solved puzzle. It is an ongoing conversation between the living and the dead, between past and present science. Archaeologists caution against overreach. The temptation to assign mystical or technological explanations is strong, but evidence demands restraint. The pyramids were born of human labor, guided by divine belief, not by lost machinery or alien science. Still, it is precisely their human origin that makes them so astonishing. They show what collective intelligence and organization can achieve without engines or steel. They prove that mastery of simple principles, leverage, friction, measurement, can yield wonders that seem supernatural. Standing before these ancient giants, one feels both humbled and challenged. The stones speak without sound, yet their message is unmistakable. Understand us, if you can. Each block is a word in a language that we are only beginning to read. And to read it fully, we must combine history with physics, faith with observation, imagination with evidence. That is what the new generation of researchers is doing. They are listening to the silent heart of the pyramid, with instruments sensitive enough to catch whispers of cosmic radiation. Through their work, the pyramid itself becomes an experiment in deep time. Perhaps the real question is not who built the pyramids, but what they built into them. Were they monuments to kings, or to the idea that matter can embody eternity? Every angle, every alignment, every hidden space suggests a plan far greater than mere burial. These structures reach beyond their age, beyond their builders, and into our imagination. They invite us to wonder whether power lies in engines and energy, or in the unyielding will to leave behind something that outlives us all. As the night deepens, the stars wheel slowly over the desert. Cosmic particles rain invisibly through the atmosphere, striking the stone, passing through it, revealing its secrets one by one. The story of the pyramids now enters a new phase, where archaeology meets astrophysics. The next chapter belongs not to kings or priests, but to scientists armed with detectors, measuring the invisible traces of the universe itself. for to see inside a mountain of stone, we must borrow the light of the cosmos. Muons, born in the explosions of stars, will guide us through what human eyes could never pierce, and with them, the search for what truly powers the pyramids begins anew. High above the Earth, in the thin air where the atmosphere fades into space, invisible particles are born. They come from distant cataclysms, supernovae, the explosive deaths of stars, and from even more mysterious origins, the collisions of cosmic rays that travel through the universe at nearly the speed of light. When these cosmic rays strike atoms in the upper atmosphere, they create showers of subatomic fragments. Among them are muons, ghost-like cousins of the electron, heavier, faster, and astonishingly penetrating. Every second, millions of muons pass through your body, through buildings, through mountains, and through the pyramids of Egypt. For centuries, humans stared at the pyramids and saw only stone. Now, physicists have learned to see through them. Muon radiography, or muography, turns the pyramid into a screen for cosmic particles. The principle is simple, though the technology is subtle. When muons pass through matter, they lose energy depending on the density and thickness of the material they cross. By placing detectors around or beneath a structure and measuring how many muons make it through from different angles, scientists can reconstruct a map of what lies inside, just as medical X-rays reveal bones beneath skin. Only, instead of using a laboratory beam, the universe provides the radiation for free. In the mid-20th century, the first experiments with muon imaging were carried out inside volcanoes to study magma chambers. The same physics applies to the pyramids. A block of limestone is dense enough to stop many muons, while an empty cavity lets more pass through. By counting these invisible visitors, detectors can produce images of hidden voids, rooms, corridors, or even narrow shafts carved deep within the pyramid's body. The resolution is coarse compared to medical scans, but the reach is enormous. Muons can penetrate hundreds of meters of rock. They are nature's own scanners, particles of the stars passing through the heart of the Earth. To the archaeologists working at Giza, this idea sounded like magic at first. The pyramids have been studied for centuries, yet most of their mass remains inaccessible. Carving into them is forbidden. Even the smallest intrusion risks damage. But muography offered a way to look within without touching a single stone. It turned physics into archaeology. When the Scan Pyramids project began in 2015, it brought together physicists, engineers, and Egyptologists in a collaboration unlike any before. Their mission was simple in theory and revolutionary in practice: to map the interior of the Great Pyramid using particles from space. At the same time, other teams explored the outer layers using infrared thermography. Every object radiates heat, and by measuring subtle differences in temperature across the pyramid's surface, researchers can detect anomalies that betray hidden cavities or differences in material. A hollow space beneath the surface cools and warms at a different rate than solid stone. On cold desert nights and blazing days, these thermal signatures stand out like invisible fingerprints. The first infrared scans revealed a handful of hotspots, places where the stone temperature diverged by only a few tenths of a degree Celsius, yet enough to suggest voids within. By combining muography and thermography, scientists could cross-check results. A void seen in both methods would almost certainly be real. The process resembles combining medical scans, X-ray, magnetic resonance, and ultrasound to form a composite view. Each method alone has limits. Muon data can be blurred by statistical noise, and infrared readings can be affected by sunlight or wind. But together, they yield a sharper picture. Slowly, the inner pyramid emerged from the data, like a shadow rising from stone. Inside laboratories near Cairo and Paris, researchers processed billions of muon detections, using supercomputers to convert particle trajectories into three-dimensional models. What appeared was startling. Voids where no voids should be. Regions of unexpectedly low density above known chambers. The precision of the data left little doubt that something enormous was hidden inside. But what exactly? Empty air? Loose stone, or some unknown architectural space? The pyramid, once a monument of certainty, became a new frontier of uncertainty. This was not merely archaeology, it was physics applied to history. The detectors themselves were marvels of engineering. Some used nuclear emulsions, photographic plates sensitive enough to record individual muon tracks. Others used gas detectors or scintillator panels that flashed tiny bursts of light when struck by a particle. Each technology offered a different balance of sensitivity and stability. The instruments were placed in the Queen's chamber, in tunnels carved during earlier expeditions, and even outside the pyramid, oriented toward its heart. Over months and years, cosmic particles did the slow work that excavation could never achieve. The deeper scientists looked, the more clearly they saw that the Great Pyramid is not uniform. Its interior is a labyrinth of densities, voids, and possibly undiscovered chambers. Yet, none of this could have been predicted from the outside. The precision masonry, the polished limestone once covering its surface, hides every hint of complexity beneath a cloak of geometry. It is as if the builders designed it not only to endure, but to conceal. Still, these discoveries did not come easily. Muon detection is a science of patience. Each particle carries only a faint trace of information, and it may take years to accumulate enough data to form an image. Detectors must operate continuously, exposed to the elements, yet shielded from dust, vibration, and heat. Scientists must subtract background noise from cosmic events, filter for trajectories, and calibrate instruments with mathematical rigor. What emerges in the end is not a photograph, but a map of probability, a ghostly image drawn in particles from distant stars. Such an image is humbling. It reminds us that the universe itself helps us uncover our past. The same cosmic radiation that shaped planets and stars is now helping to reveal how humans shaped their own monuments on Earth. Through this lens, the boundary between the cosmos and the pyramid begins to blur. Both are ancient structures built by forces of matter and energy, one by nature, the other by human hands. The promise of these new eyes into stone is staggering. If Muons can reveal hidden rooms, they could also refine our understanding of how the pyramid was constructed. They might show internal ramps, counterweight shafts, or zones of lighter fill that served as structural buffers. Each anomaly is a clue waiting to be interpreted, and as the detectors continued their silent watch, the data began to hint at something extraordinary. A large, empty region high above the Grand Gallery, a cavity where none should exist. That discovery would ignite one of the most heated debates in modern archaeology, reviving questions long thought settled and forcing scientists to reimagine the pyramid's design. It was a revelation that no one had predicted, drawn not by human hand, but by the fall of cosmic rain from space. The news broke quietly at first, in academic papers and cautious conference announcements. In the year 2017, the Scan Pyramids team revealed evidence of a massive cavity deep within the Great Pyramid, a space roughly 30 meters long, located above the Grand Gallery. They called it simply the Big Void. It was the first major internal discovery in the pyramid since the 19th century. The revelation rippled through both science and archaeology, igniting headlines and debates. Had modern physics finally uncovered a hidden chamber that had lain untouched for over 4,000 years? The finding came not from a single measurement, but from 3 independent methods of muon detection. Nuclear emulsion films developed in Japan recorded microscopic tracks left by cosmic particles as they passed through the pyramid. Scintillator hodoscopes, built by European laboratories, detected flashes of light, created when muons interacted with sensors. Gas detectors, used by a third group, measured the ionization trails left in their chambers. Each method carried its own limitations, yet all 3 pointed to the same conclusion. An unexpected void existed in that precise location. The data was unmistakable. Muons passing through the region above the Grand Gallery arrived in greater numbers than they should have if that volume were filled with solid limestone. The excess was consistent with an empty or low-density space, roughly the size of a passenger jet fuselage, stretching parallel to the Grand Gallery itself. The chance that this signal was random was vanishingly small. Something real was there. What it was, however, remained a mystery. The scientific community responded with both excitement and restraint. To physicists, the discovery confirmed the astonishing sensitivity of mography. To Egyptologists, it raised new questions that archaeology alone could not yet answer. Was the void a secret chamber left sealed since antiquity? A structural cavity designed to relieve weight? or a remnant of some forgotten construction phase. Until further measurements or limited exploration could verify it, speculation remained open. The team behind the discovery approached the results carefully. They emphasized that a void is not automatically a room. The pyramid's internal structure already contains relieving chambers above the king's chamber, spaces intentionally designed to divert the immense load of stone pressing down from above. The new cavity could be a larger example of the same engineering principle, yet its position and scale seemed unusual. It lay higher than the relieving chambers, misaligned with known features, and larger than any expected structural gap. It appeared, quite literally, to be a room where no room should be. Public imagination, as always, raced ahead. Some envisioned hidden burial chambers waiting to be opened, others proposed mechanical functions, and a few revived the idea of the pyramid as a vast energy device. The scientists themselves remained grounded. The data told them only that an empty space existed. Nothing more, nothing less. Yet even this bare fact carried enormous implications. It meant that after centuries of study, the Great Pyramid could still surprise us with unseen architecture. In laboratories, the Scan Pyramids team refined their models. They reconstructed the pyramid's interior using computer simulations that matched the Muon flux data. The resulting images showed the Big Void as an elongated region, similar in cross-section to the Grand Gallery, possibly extending dozens of meters toward the core. Its exact shape, however, could not be determined without higher resolution scans. The detectors had reached the limits of their sensitivity. To learn more, new generations of Muon sensors would be needed, ones capable of mapping density variations with unprecedented precision. Infrared thermography provided a faint echo of support. Thermal imaging of the pyramid's northern face had revealed subtle anomalies near the same altitude as the Muon-detected void. Though inconclusive, the coincidence suggested that the cavity might influence how the surrounding stone stored and released heat. It was another thread in the growing web of evidence that the Great Pyramid's interior was far more intricate than the textbook cross-section suggested. For the physicists, the discovery was also a triumph of patience. Years of data collection, billions of particle detections, and the careful elimination of statistical noise had culminated in one clean signal. It was as though the cosmos itself had whispered back through their detectors, telling them there was more to find. For the archaeologists, it was a reminder of humility. Even the most studied monument on Earth could still hold secrets that only the universe's own radiation could reveal. Still, one question lingered above all others. What was the purpose of this void? If it was simply a structural feature, why was it so large? And why did it mirror the Grand Gallery's form? Could it have served as a hidden relieving system, balancing the stress of stone above? Or was it an intentional cavity meant for symbolic or ritual purposes, perhaps never meant to be entered by the living? Without direct access, the answers remained locked behind millions of tons of limestone. The Egyptian authorities faced a delicate choice. Opening or drilling into the pyramid risked irreversible damage, yet leaving the mystery unsolved frustrated scientific curiosity. For now, caution prevailed. The detectors would continue to watch, and new generations of technology would refine the picture. Meanwhile, the Big Void became a focal point for both scholarly debate and public wonder. It was the closest thing to a new discovery inside the pyramid in modern times, a reminder that even after 40 centuries, the monument still held its breath. This event marked a turning point. The fusion of archaeology and particle physics had proven not only possible but powerful. The same tools used to study volcanoes and nuclear reactors were now rewriting human history. And with every passing cosmic ray, a clearer image of the pyramid's inner world took shape. But the Big Void was not the only surprise hidden beneath the sands. As attention turned to other parts of the Giza plateau, new anomalies began to emerge, patterns in the earth itself that hinted at buried structures, corridors and chambers beyond the pyramid walls. The discovery of the Big Void changed everything. For years, scientists had suspected that more secrets might lie buried within the Great Pyramid, but few expected evidence of such magnitude. The revelation emboldened teams to expand their investigations beyond Khufu's monument. If Muons could uncover hidden spaces inside one pyramid, perhaps they could do the same across the plateau. The desert, after all, is not just sand and stone. It is a layered record of time. Beneath its surface lie the echoes of forgotten architecture, waiting for instruments sensitive enough to hear them. Ground-penetrating radar soon joined the effort. This technology sends pulses of radio waves into the Earth and measures how they reflect off subsurface structures. Different materials, rock, sand, voids, or walls, reflect signals differently, allowing scientists to map what lies below without digging. Near the Giza necropolis, radar surveys revealed shapes no one expected: long corridors, L-shaped foundations, and patterns resembling buried walls aligned with ancient axes. Electrical resistivity tomography, which measures how easily electric currents flow through the ground, confirmed these anomalies. Together, the scans painted a ghostly image of an unseen network beneath the sand, as if the entire plateau were the upper floor of a deeper city. What were these shapes? Some matched known tombs and mastabas, but others had no corresponding surface markers. One complex near the Great Pyramid appeared to connect with deeper zones, as though part of an older infrastructure hidden beneath later construction. Scholars debated whether these were natural cavities, storage spaces, or ritual tunnels built to channel water or air. The data could not yet distinguish between them, but the geometry was too regular to be coincidence. Beneath the graves of nobles and workers, the desert seemed to hold architectural intent. At first, Egyptologists approached these results with caution. Radar and tomography are powerful, but imperfect. Wet sand, mineral veins, or modern disturbances can distort readings. Yet, as more surveys overlapped, the patterns persisted. Some anomalies appeared at depths greater than 30 meters, aligned with the orientation of the pyramids themselves. The notion began to circulate that the builders may have designed the plateau as a unified system, temples above, corridors below, each mirroring the other in scale and direction. The public imagination, fueled by headlines, leapt again toward hidden machines and lost technology. Scientists countered with realism. Nothing in the data implied engines or power sources. These were voids, not reactors, chambers, not turbines. But even without fantasy, the implications were profound. The buried structures might hold the keys to understanding the logistics of pyramid construction, the quarries, ramps, and supply routes now swallowed by sand. They could explain how materials moved, how workers lived, and how the complex evolved over centuries. As scanning expanded, attention turned to the mastaba fields surrounding the pyramids. Many of these flat-topped tombs had been mapped since the 19th century, yet muon and radar imaging revealed surprises beneath them. Vertical shafts extended far deeper than expected, some ending in chambers whose shapes defied known burial patterns. In one sector, overlapping cavities suggested multi-level construction, possibly indicating reuse or modification over generations. These discoveries blurred the line between tomb and infrastructure. Perhaps the mastabas were not merely graves, but part of a broader architectural machine, a network designed to balance the forces of nature, ritual, and geometry. The desert itself became a laboratory. Engineers carried portable sensors across dunes at night to escape the heat, their equipment tracing invisible outlines beneath their feet. Every new dataset added dimension to a landscape once thought fully known. The image emerging from the combination of tomography, radar, and electrical tomography was astonishing. A terrain riddled with cavities, channels, and dense stone regions, forming a hidden anatomy beneath Giza's visible monuments. Still, the meaning of these findings remained elusive. Were these cavities simply relics of quarrying? Could they be remnants of ancient infrastructure used during construction? Or had the builders deliberately left them as symbolic voids, echoing the chambers within the pyramids themselves? Archaeologists and physicists debated late into the night, each discipline seeing the same data through different eyes. To one, the anomalies were artifacts of geology; to another, evidence of lost engineering. The collaboration between these fields became essential. Physicists needed archaeological context to interpret their graphs. Archaeologists needed physics to see beyond the reach of shovels. Together, they were constructing a new way of doing history, one that replaced excavation with imaging and conjecture with measurable probability. For the first time, science could sketch what lay beneath Egypt's most sacred ground without disturbing a grain of sand. As the new maps took shape, a deeper question arose. Were these voids merely functional, or were they intentional parts of a design that extended beyond practicality? Could the Egyptians have used cavities and densities not only to manage weight, but to manipulate flow of air, of water, of sound? Such speculation hovered on the border between engineering and mysticism, yet it was impossible to ignore. The pyramids had always been more than structures. They were expressions of cosmic balance. If these newly found spaces formed an interconnected system, their purpose might have been as symbolic as it was structural. The discoveries beneath the sands set the stage for a more radical idea, one that scientists approached with both fascination and skepticism. Perhaps the pyramids were not just monuments to eternity, but machines of stone, devices that harnessed physical principles still not fully understood. Whether those principles involved sound, resonance, or hydraulic balance remained to be seen. The next wave of research would delve into that possibility, examining whether the geometry of these colossal structures could itself generate or channel natural forces. The story of the Big Void begins, like many discoveries in science, not with certainty, but with a pattern in data that refused to vanish. When the Scan Pyramids team first assembled their detectors inside the Great Pyramid, they expected to confirm what was already known: the King's Chamber, the Queen's Chamber, and the Grand Gallery, connected by narrow corridors and ascending shafts. Nothing more. The detectors would test the precision of mography in an environment of global attention, and perhaps refine the internal map of the monument. But then, the cosmic rays began to write their silent signature across the instruments, and what they revealed changed everything. It began as an inconsistency. The number of muons arriving from one particular direction, high above the Grand Gallery, was greater than predicted by models of uniform limestone. The difference was not large, but it was persistent. Day after day, as billions of particles passed through, the excess remained. The team checked calibration, repeated measurements, replaced equipment. The signal stayed. That was when they realized something extraordinary. There was less stone in that region than there should be. The pyramid's density map had a hole, invisible to the eye but clear in the data. To confirm it, they turned to redundancy. 3 independent methods, each based on a different detector technology, were deployed. Nuclear emulsion plates, as delicate as photographic film, recorded fine traces of passing muons that could later be analyzed under microscopes. Scintillator hodoscopes, layered panels that flash light when struck by particles, offered real-time digital readouts. Gas detectors, filled with special mixtures that ionize under muon impact, provided another layer of verification. When all 3 instruments, working in different locations and times, showed the same excess of muons from the same angle, the conclusion became undeniable. There was a cavity, a massive one. The scientists named it the Big Void. Their calculations suggested a length of roughly 30 meters, though its width and shape were less certain. It sat directly above the Grand Gallery, following a similar orientation. This symmetry deepened the mystery. If it were a relieving chamber, why was it so large? If a construction gap, why placed so precisely? And if an intentional room, why sealed so completely that no known passage led to it? The world reacted with awe. Headlines spoke of secret chambers and lost kings. Speculative theories flourished. Some saw it as a hidden sanctuary designed for royal relics. Others imagined it as a structural experiment, an internal void used to redistribute weight in a way that modern engineers had not yet understood. Egypt's Ministry of Antiquities maintained a careful neutrality, confirming the scientific data but forbidding any physical intrusion. The Great Pyramid, they insisted, must remain untouched until new methods could explore it without harm. For the scientists, this restraint was both frustration and inspiration. They had glimpsed something extraordinary through cosmic radiation, yet they could not reach it. In a sense, the Big Void became a mirror of the human condition. Knowledge visible but unreachable, a truth glimpsed through probability. Teams began to design new generations of detectors, capable of higher resolution and more precise angular tracking. If the current data could only sketch the cavity, Future instruments might reveal its exact shape, perhaps even distinguish whether it contained air, rubble, or layered stone. In Paris, researchers refined the simulation software that transformed raw muon counts into images. They ran countless models, altering stone density, orientation, and geometry. Every simulation that fit the data pointed to the same conclusion: an elongated hollow space, tilted slightly, stretching through the core of the pyramid like a hidden artery. It was not a random feature. Its geometry aligned with the main structural axes, suggesting it was part of the original design. Infrared thermography offered faint corroboration. Subtle heat anomalies appeared on the pyramid's northern face, near the level of the suspected cavity, implying a discontinuity in thermal conduction. The pyramid's massive stones absorb and release heat at predictable rates, but a void or air-filled space disrupts that rhythm. Although not definitive proof, the correlation between infrared and muon data strengthened the case that the big void was real. And yet, its purpose remained unfathomable. If it were a relieving chamber, it was the largest and most unusual ever constructed. If it were symbolic, it must have held meaning now lost to time. Some theorists propose that it could be an unfinished or abandoned construction phase, sealed and forgotten when plans changed. Others speculated that it might serve to reduce resonance or balance stress across the Grand Gallery's high ceiling. Still others, operating on the edges of accepted theory, suggested that the void might interact with acoustic or vibrational properties of the pyramid, forming part of an ancient energy design. The scientists involved dismissed such claims, emphasizing that the void's discovery revealed no mechanism, only space. But they acknowledged that its precision and symmetry demanded explanation. Months turned into years as teams worked to refine the map. Every improvement in resolution brought new complexity. The void appeared not as a simple rectangle but as an irregular corridor, possibly divided by unseen partitions or filled with lighter materials rather than air. The data hinted at density gradients, suggesting that it might not be completely empty. Perhaps it contained rubble, sand, or even wooden scaffolding left from construction. Without direct access, no one could say. The big void stood as a paradox, a space both known and unknowable. It existed in equations, in data points, in three-dimensional models rendered by supercomputers, but not yet in human experience. No camera had ever glimpsed it. No explorer had walked its floor. It was a chamber defined entirely by cosmic particles that were themselves born in the death of distant stars. In a poetic sense, the universe had become our archaeologist, revealing history through radiation that had traveled billions of years to reach us. The implications extended beyond Egypt. Muon imaging was now being applied to cathedrals, temples, and even industrial structures around the world. The pyramids had once again become a laboratory, not for ancient engineers, but for modern ones. What Khufu's builders left in stone, today's scientists were deciphering in light. The big void was more than a discovery. It was a demonstration of how far human perception had evolved. Where once we dug, now we listened to the cosmos. As the data accumulated, one realization grew clear. The Great Pyramid was not a solid monolith, but a layered complexity of chambers, cavities, and densities, each one purposeful, each one balanced. The big void did not diminish its mystery, it deepened it. For if there was one such hidden chamber, how many more might lie unseen? The answers waited in the quiet rain of muons falling through the desert sky, marking their invisible paths through eternity. When the first images of the big void reached the scientific world, they were hailed as proof that even the most studied monument on Earth could still surprise us. Yet, the discovery was only the beginning. The instruments that had glimpsed the unseen were turned outward, toward the wider Giza plateau. The desert around the Great Pyramid, long believed to be fully mapped, soon revealed a new language of shadows buried beneath the sand. What the archaeologists began to see was not just one anomaly, but a network, patterns that hinted at a complexity far beyond a single structure. The landscape of Giza has always been more than the three pyramids. Around them lies a city of the dead, a vast necropolis of tombs, causeways, and temples. Over millennia, drifting sand had buried much of it. For generations, excavation focused on the grand monuments, the pyramids of Khufu, Khafre and Menkaure, while the surrounding fields of mastabas and shafts were treated as secondary. But the new generation of technology invited a different approach. Instead of digging, scientists began to listen to the Earth itself. Ground-penetrating radar became their primary tool. By sending electromagnetic pulses into the ground and recording the echoes that bounced back, it created images of buried structures. Each layer of soil, each shift in density, reflected the waves in distinct ways. When combined with electrical resistivity tomography, which measures how easily currents pass through underground materials, the result was a kind of X-ray for the desert. The images that emerged astonished the teams. Beneath the sand north of the Great Pyramid, they found straight walls, intersecting corridors, and even right-angled voids that no previous maps had recorded. At first, some thought the signals were noise, interference from metal debris or uneven sand moisture. But repeated scans under varying conditions confirmed the shapes. The patterns were deliberate. One formation resembled an L-shaped complex, buried several meters deep, its orientation aligned precisely with the cardinal directions, just like the pyramids above it. Another appeared as a long vertical shaft connecting to a broader horizontal cavity, too regular to be natural. These were not random voids or cracks in limestone. They were built spaces constructed by hands that had vanished into history. Smithsonian researchers working alongside Egyptian authorities cautiously interpreted these results. Perhaps they were undiscovered tombs or extensions of known ones. Some could be storage chambers or areas where unfinished projects were abandoned and later buried. But others lay directly beneath causeways and temples, suggesting a more intricate plan, one that connected surface and subsurface structures in ways no one had imagined. If confirmed, it would mean that the builders of Giza designed the necropolis as a multi-layered complex, as if the living world of stone were mirrored by an invisible twin beneath. The data grew richer as radar resolution improved. Near the Western Cemetery, scientists detected what appeared to be circular voids, arranged in geometric patterns, each several meters wide. Some researchers proposed they could be ancient wells or storage silos. Others suggested ritual pits associated with funerary practices. The electrical resistivity readings showed contrast too strong for simple soil disturbances. Whatever lay below, it had volume and form, echoing the precision seen in the visible architecture above. Even more intriguing were anomalies near the Sphinx. Scans revealed discontinuities in the bedrock, as though chambers or tunnels extended beneath the monument's pores. This idea was not new. It had been whispered since the 19th century, but now physics offered measurable support. While no definitive chamber was confirmed, the data suggested hollow zones, possibly natural fissures expanded by ancient engineers. For Egyptologists, these results reopened old debates about whether the Sphinx was part of a grander subsurface system connected to the pyramids themselves. What made these findings revolutionary was the realization that Giza might not be a collection of isolated monuments, but a single integrated complex, an engineered landscape. The ancient builders had shaped not only stone, but also the ground itself, carving, filling, and layering until architecture and geology became one. The necropolis was not built on the desert, it was built into it. Every angle, every axis, every buried feature seemed to obey an invisible geometry that linked sky, horizon, and underworld. As the evidence mounted, interpretations multiplied. Some scholars suggested that the underground network served purely functional purposes, quarries, drainage channels, or construction ramps later filled in. Others argued for a more symbolic role. In Egyptian cosmology, the underworld, Duat, was a mirror of the heavens, a realm through which the soul traveled after death. Could the builders have replicated this concept physically, embedding passages beneath their monuments to represent the path of the soul? If so, the plateau itself would be a cosmological diagram carved into the desert. Still, the scientists approach these theories with caution. Ground-penetrating radar can be deceptive. Differences in soil composition or moisture can mimic man-made shapes. Only excavation can confirm what lies below, and excavation here is slow, bound by strict preservation laws. Yet, Even with these limitations, the consistency of the anomalies across multiple techniques was hard to ignore. Every new scan deepened the puzzle. The technology also revealed a curious fact. In several places, the anomalies clustered near older excavation sites, as if previous generations of explorers had unknowingly stopped just short of discovery. Areas dismissed as empty desert were now alive with signals of buried architecture. Teams began to overlay the radar maps with historical records correlating ancient descriptions with modern data. The alignment was uncanny. Some of the newly detected shapes corresponded to areas mentioned in Old Kingdom inscriptions as houses of eternity or fields of offering. The idea that these were purely metaphorical began to fade. The combination of muon imaging and ground-based scans transformed Giza from a static monument into a dynamic system. The pyramids, the tombs, and the earth between them were no longer separate entities but parts of a single design, a landscape engineered to embody cosmic and earthly order. This realization echoed through every discipline involved. Archaeologists spoke of the resurrection of buried architecture. Physicists spoke of mapping density and emptiness, as if charting the anatomy of an ancient planet. Together, they were uncovering the hidden infrastructure of belief. In the midst of this renaissance of discovery, one question began to dominate conversations. If these voids and corridors are not random, what purpose did they serve? Could they be part of a mechanical or hydraulic system, an ancient network that managed forces we no longer recognize? Or were they simply spaces of ritual and symbolism, crafted to ensure the pharaoh's passage into eternity? The data alone could not decide. But for the first time, the mystery extended beyond the pyramids themselves. The entire plateau had become an instrument of revelation, responding to the same cosmic rain of particles that had unveiled the Big Void. What was emerging from the sand was a vision of ancient Egypt, not as a series of isolated miracles, but as a single, unified act of design, one that fused astronomy, engineering, and spiritual geometry into a blueprint for eternity. When the question arises of how the ancient Egyptians built the pyramids, imagination often leaps to lost technologies or extraterrestrial hands. Yet, the truth, though more human, is no less extraordinary. The pyramids are the result of a civilization that mastered the physics of stone through observation, patience, and sheer endurance. Their engines were not powered by metal or fuel, but by gravity, water, and will. To modernize, the achievement appears impossible, but to those who lived it, it was a matter of geometry, craft, and devotion carried out at a scale the world had never seen. Archaeology tells us that the Egyptians worked with tools of copper, dolerite, and sand. Copper chisels, when hardened by repeated hammering, were capable of carving limestone with surprising precision. For harder granite, workers used pounding stones of dolerite, a dark, volcanic rock nearly as tough as the material they shaped. Experiments by modern stonecutters have shown that repeated impacts of dolerite, guided by lines etched into the surface, can produce flat planes accurate to within millimeters. In the blazing light of the Egyptian sun, thousands of these pounding stones littered the quarries, silent witnesses to the labor of generations. To cut finer channels and drill holes, the builders turned to abrasive sands. A copper tube, rotated back and forth with a wooden bow and mixed with wet quartz sand, could bore through granite. The sand, harder than both copper and granite, acted as the cutting edge. Archaeologists have replicated this method, demonstrating that holes and cores identical to those found at Giza can be made using these simple materials. It was not magic, it was persistence measured in thousands of revolutions per hour, powered by muscle and patience. But carving stone was only the beginning. The true challenge was motion. How do you move blocks weighing tens of tons across miles of desert and up the side of a pyramid hundreds of feet tall? The answer lies in the subtle manipulation of friction. Ancient inscriptions and experiments reveal that water played a critical role. Workers poured water in front of the sledges that carried the stones, dampening the sand and allowing it to compact. The thin layer of moisture created a temporary hardness that reduced drag by nearly half. On this firmed path, teams of men could pull blocks more efficiently than any dry route would allow. This technique has been proven by modern physicists using models and sand from the Giza region. When sand is perfectly dry, it clumps and resists movement. When too wet, it turns to mud. But at just the right moisture, it binds together, forming a surface that holds weight without collapsing. The ancient builders, through observation, had discovered the precise balance point between dryness and saturation, a form of environmental engineering that predates the science of friction by millennia. Moving stone horizontally was one challenge, lifting it was another. For centuries, scholars argued over the nature of the ramps used to raise blocks. The traditional theory suggests long straight ramps extending from the plateau to the growing pyramid. Yet, calculations reveal that such ramps would have required more material than the pyramid itself. Others propose spiral ramps winding around the structure's exterior, but evidence for such massive remains is scarce. A more recent and elegant hypothesis, proposed by architect Jean-Pierre Houdin, imagines an internal ramp, a corridor that spirals upward within the pyramid's body, hidden behind the outer casing. Computer simulations and limited scans lend credibility to this idea. The internal ramp would have allowed continuous construction without an external mountain of debris. As each level rose, stones could be dragged upward along a gently sloping path using wooden sledges and lubrication. Turning chambers at corners would have redirected the route inward, maintaining both efficiency and stability. Though still debated, the theory aligns with the engineering logic of minimizing effort and protecting geometry. Other researchers point to counterweight systems. By channeling water or sand into shafts, builders could have balanced massive loads, raising them incrementally using the power of gravity itself. Archaeological evidence from later Egyptian sites shows the use of simple levers, pulleys, and balance beams for moving obelisks. It is not impossible that early versions of these principles were applied at Giza. The Egyptians understood leverage intuitively. They built cranes of wood and rope long before iron and steel made such machines common. Still, even with these methods, the scale remains staggering. To construct the Great Pyramid, more than 2 million limestone blocks had to be cut, transported, and set with precision in less than 30 years. That required logistics of astonishing sophistication: food supply chains, housing for workers, schedules timed to the Nile's floods. Excavations of the workers' village reveal bakeries large enough to feed thousands, breweries for daily rations of beer, and administrative tablets listing teams, shifts, and delivery quotas. This was not slave labor, as once imagined, but a national project coordinated like an ancient industrial operation. The Egyptians also understood the physics of balance and load. Inside the pyramid, they built relieving chambers, stacked layers of granite beams that redirected pressure away from the king's chamber. The design resembles modern stress distribution systems used in skyscrapers. It shows an intuitive mastery of weight, vibration, and tension. The same knowledge appears in the subtle curvature of the pyramid's sides, a slight inward bow that prevents optical distortion and structural weakness. Every line, every angle had purpose. Among the most fascinating discoveries is the use of water, not only as a lubricant, but possibly as a stabilizing element. Some researchers have proposed that underground channels near Giza once carried water from the Nile closer to the construction site. This would have allowed barges to deliver stone blocks directly to the base of the plateau, reducing transport distance dramatically. Geological surveys show that the Nile's course once ran much nearer to the pyramids than it does today. If true, the builders harnessed natural geography as part of their machinery, blending environmental knowledge with architectural ambition. None of these techniques involve electricity or engines, yet together they form a system of mechanical genius. The Egyptians transformed the simplest forces, gravity, friction, buoyancy, into tools of precision. Their machines were made not of metal gears but of geometry. They built with the understanding that nature itself could be guided, that a mountain could be moved by water, stone, and alignment. And still, questions linger. Were there hidden mechanisms within the pyramid itself, internal ramps, counterweight shafts, or passageways used to control movement during construction? The Muons scans, revealing cavities like the Big Void, reignited these speculations. Perhaps those spaces were not ceremonial at all, but remnants of construction infrastructure sealed when their purpose was complete. If so, the pyramid we see today might be both a tomb and a fossilized machine, the the solid remains of an operation frozen in stone. Such a vision bridges myth and science. The Great Pyramid is a self-contained engine, not of energy, but of balance. Its power lies not in motion but in the mastery of stillness, the ability to hold millions of tons in eternal equilibrium. The structure breathes without moving, channels force without breaking. It is the ultimate machine of stability, designed not to act, but to endure. The tools may have been simple, but the planning behind them was anything but. The builders of the Great Pyramid were not improvising. They were following a design rooted in mathematical and astronomical precision. Every block, every ramp, every level of stone was part of a vast equation written in geometry. The Great Pyramid is aligned with true north to within 1/15 of a single degree, a precision unmatched until the invention of the modern theodolite. This accuracy was not an accident of luck, but the product of instruments and measurements that reflect an astonishing understanding of Earth's motion. Archaeologists have found evidence of alignment pits dug into the plateau, used by ancient surveyors to sight the rising and setting of particular stars. They may have tracked the rotation of stars near the celestial pole, adjusting for precession through repeated observation. By watching these stars cross the same point on the horizon at dusk and dawn, the Egyptians determined a line of perfect east and west. From that, they built a grid that guided every stone. Such precision implies a long tradition of astronomical measurement, a kind of ancient observatory where sky and earth met in the service of architecture. Yet the mystery of construction remains layered. The internal ramp theory, though compelling, cannot explain all aspects of the pyramid's formation. Some engineers propose hybrid methods: external ramps for the lower tiers, internal corridors for higher levels. Others point to cranes and lever systems using wooden A-frames. Still others to sand pits and counterweights. The truth may combine all these techniques, each adapted to a specific stage of the build. What matters most is that the methods worked, not through hidden technology, but through perfect organization. Recent computer simulations have reconstructed how teams of laborers might have coordinated their efforts. A single block weighing 15 tons could be pulled by 50 men on a lubricated sledge, advancing slowly up a ramp of compacted clay and gypsum. Supervisors tracked the progress using ropes and sightlines to ensure level placement. Each block's position determined the next. The entire structure was a chain reaction of geometry. One misaligned stone could compromise the slope, so constant measurement was vital. The builders likely used sighting rods, plumb lines, and water levels, tools of basic physics that remain essential even today. The pyramid's interior also reflects this sophistication. The Grand Gallery, with its high corbelled ceiling and steep incline, has puzzled researchers for centuries. Its function remains uncertain, yet its engineering is remarkable. The stepped roof distributes the weight of stone evenly, preventing collapse. The gallery may have served as a ramp for hauling granite blocks into the king's chamber, using counterweights and rollers. Others think it was purely ceremonial, symbolizing the ascent of the pharaoh's soul. In either case, the gallery's design shows an understanding of stress management and vertical motion. It is a passage that unites mechanical and spiritual purpose. The presence of the relieving chambers above the king's chamber reinforces this theme. These 5 spaces, separated by massive granite beams, act as cushions that spread the immense load of the pyramid's upper layers. The beams themselves are masterpieces of quarrying, cut and positioned so precisely that even today, engineers struggle to explain how they were lifted into place. The chambers do not serve the living. No one was meant to enter them. They exist solely to maintain balance, invisible yet essential. The pyramid's true power lies in these unseen mechanisms, where function hides behind stone. Some researchers suspect that water played an even larger role than previously believed. Studies of the plateau's geology indicate the presence of ancient channels beneath the site. During construction, these may have provided a natural means of transportation and possibly even acted as hydraulic stabilizers. By adjusting the water level in these channels, workers could float heavy blocks or maintain equilibrium in the foundation. This concept of water management aligns with the Egyptians' broader mastery of the Nile, which governed every aspect of their civilization. The same knowledge that allowed them to irrigate their fields may have guided them to engineer their monuments. Experiments at modern replicas suggest that if the pyramid's internal corridors were partially filled with water, they could form buoyant pathways, essentially hydraulic elevators, where stones could be raised or lowered with minimal effort. No direct evidence confirms this, yet it remains one of the most elegant hypotheses. It represents the Egyptian genius for merging natural forces with human intent. They did not fight gravity, they partnered with it. The builders' understanding extended even to the composition of their materials. The limestone used for the outer casing was quarried locally, while the harder granite for the king's chamber came from Aswan, nearly 800 kilometers to the south. Transporting such heavy stones along the Nile required careful timing with the river's floods. Barges carried them northward when the water rose high enough to reach loading ramps near the plateau. Once at Giza, the stones were hauled along prepared roads, some of which still show the marks of wooden rollers and ropes. These operations demanded not only physical strength but bureaucratic precision. Archaeologists have found papyri that record deliveries of materials, food rations for workers, and inspection schedules for teams. Each task was overseen by scribes who tracked progress in real time, ensuring that labourers were rotated, rested, and fed. Far from a society of slaves, this was a community of skilled artisans and engineers united under a sacred national project. The Great Pyramid was the expression of their collective order, a civilization organized around harmony and measured perfection. Even the choice of dimensions reveals a deeper logic. The ratio of the pyramid's height to the perimeter of its base approximates 2 pi, linking the geometry of a square to that of a circle. Whether by coincidence or design, the result unites heaven and earth in mathematical harmony. This same principle appears in Egyptian art and architecture, where proportions often reflect cosmic relationships. The pyramid's slope, near 51 degrees, corresponds to the angle of sunlight at the latitude of Giza during specific times of the year. In this way, the pyramid becomes a frozen calendar, a stone recording of celestial cycles. In all of this, there is no need for mythical machinery or lost energy sources. The real technology of the Egyptians was conceptual, an integration of physics, mathematics, and spiritual symbolism into a single architectural form. The pyramid is both a machine and a message, a device for eternity, built to operate not in motion but in endurance. Every surface, every chamber, every grain of sand beneath it participates in that balance. Still, modern curiosity refuses to rest. Each time a new void or anomaly is found, speculation surges again. Could some cavities have served as counterweight shafts, operating like pistons of air or water during construction? Could vibrations or sound have played a role in stabilizing or testing alignment? None of these ideas have been proven, yet their persistence shows how deeply the pyramid challenges our understanding of engineering. Even knowing the tools and techniques, the sheer scale defies easy explanation. The builders worked at the threshold of physical possibility, balancing precision and chaos. What emerges from this study is not the image of a primitive society, but of a culture that understood how to convert the natural world into a cooperative system. The pyramid was their laboratory, their cathedral, their clock, and their engine. To build it was to perform an act of cosmic calibration, aligning the living and the eternal. Every ramp, every stone, was part of a ritual of physics, a transformation of effort into permanence. The deeper the study of the Great Pyramid goes, the more it seems that its construction was an act of controlled genius rather than brute force. The builders harnessed nature rather than conquering it. Every process they employed turned the desert itself into a tool. Even the heat, the wind, and the slope of the plateau were allies in the task. By choosing Giza's location with such precision, the Egyptians selected not only a site of spiritual meaning, but one of mechanical advantage. The bedrock there rises in a stable mound, reducing the need for deep foundations. The ground beneath the pyramid is not perfectly level but gently contoured, giving the monument a natural anchor that resists shifting through time. The plateau was the first piece of engineering. Excavations have revealed quarries directly adjacent to the pyramid's base. The limestone blocks for the lower courses were likely cut from this very spot, saving immense effort. Each block was pried loose by pounding narrow channels with dolerite hammers and inserting wooden wedges, which were then soaked in water. As the wood expanded, the pressure split the stone cleanly along its grain. The process was slow but predictable, producing uniform blocks that could be transported short distances by sledges. The proximity of the quarry meant that much of the pyramid literally rose from its own ground. The monument is the plateau, transformed. In the late stages of construction, the casing stones were polished to a mirror finish. These white limestone panels, some weighing several tons, were fitted so tightly that a blade could barely slip between them. Under the sun, they reflected light so brilliantly that the pyramid must have gleamed like a mountain of fire, visible from miles away across the desert. To achieve this level of finish with copper tools required an understanding of abrasion and patience on an unimaginable scale. The workers may have used powdered quartz mixed with water as a polishing compound, applied with constant pressure until the surface shone. The effect was not merely aesthetic, it was symbolic. The pyramid was meant to embody the sun's light, transforming stone into radiance. Inside, the engineering was equally precise. The passages descend and rise at exact angles, their alignments matching celestial directions. Air shafts from the King's Chamber and the Queen's Chamber point toward specific stars, the northern shaft toward Thuban, once the pole star, and the southern toward Orion's belt, sacred to the god Osiris. These alignments were not decorative. They represented the path of the soul, guiding the pharaoh's spirit toward the eternal heavens. Yet, they also show technical mastery. Carving shafts through tens of meters of stone at consistent angles required surveying skills far beyond ordinary construction. The builders were as much astronomers as masons. Many modern engineers believe the pyramid's success lies in its ratio of mass to surface area. Its wide base distributes weight evenly, and its sloping sides deflect wind and seismic vibrations. The entire structure acts as a stabilizing wedge, channeling force downward into the plateau. In essence, the pyramid is not resisting nature, it is flowing with it. Over time, as the outer casing eroded and earthquakes struck, the pyramid absorbed shock rather than breaking apart. It stands because it was designed to breathe with the planet itself. This too is a kind of machine, one that uses geometry instead of gears. In considering the pyramid as an engine, one must abandon the idea of motion. Its function is equilibrium. It converts chaos into order through design alone. The massive stones are not static. They press, balance, and counterbalance in ways that keep the whole alive. Each chamber, each void, is part of that living stability. The relieving chambers, the big void, even the hidden passages might all serve one purpose: to control stress, to ensure that the monument never collapses under its own weight. Such precision cannot be accidental. It reflects calculations and experiments performed generations before Khufu's reign. The builders inherited centuries of accumulated knowledge. This inheritance extended beyond mathematics to an understanding of sound. Inside the king's chamber, a low hum can be heard when one speaks or strikes the granite sarcophagus. The room resonates at particular frequencies, creating standing waves that amplify voices and footsteps. Acoustic studies have shown that these frequencies align with the chamber's dimensions, as though tuned intentionally. The same principle appears in other temples, where stone hollows resonate with chanting. It is not unreasonable to imagine that the Egyptians understood resonance well enough to design spaces that vibrated with ritual power. To them, sound and energy were linked. Vibration was life. In that sense, the pyramid might have been a vast resonator, a bridge between human voice and cosmic order. Water, too, may have played a hidden role long after construction. Seasonal flooding of the Nile occasionally reached the base of the plateau, and some theorists propose that these waters filled underground channels, creating subtle pressure differences that stabilized the monument. Whether or not this was intended, it would have strengthened the pyramid's bond with its environment. Stone, water, and sky worked together in silent harmony, maintaining equilibrium through the ages. Every detail points to a civilization that saw no separation between science and spirituality. For the Egyptians, to build was to worship, and to measure was to honor creation. Their tools were extensions of the natural world, their geometry an imitation of the heavens. The pyramid thus becomes more than architecture. It is an equation written in limestone, expressing unity between man, earth, and cosmos. The ancient engineers did not seek to dominate nature, but to align with it, to freeze harmony into form. When one stands before the Great Pyramid today, it is easy to forget that beneath its worn surface lies a masterpiece of integrated design, mechanical, mathematical, and symbolic. The entire structure is a mechanism of eternity, operating not in seconds or centuries, but in cosmic time. Its energy is potential, its motion invisible. It endures because it was conceived as part of the natural order, as inevitable as the sunrise over the desert horizon. In this light, the pyramid is indeed a machine, but its power is not mechanical. It is the power of mastery, the transformation of human understanding into permanence. The Egyptians discovered that true power does not come from engines or electricity, but from the ability to balance opposing forces so perfectly that time itself cannot break them. The pyramid is that balance made solid. The next question then is what that balance means. If the pyramid itself functions as a machine of equilibrium, what does it reveal about the civilization that built it? Did they believe they were imitating the mechanics of the universe, or participating in them? To explore this idea, we must step beyond engineering and into the realm of philosophy and physics, where ancient intention meets modern theory. That journey begins with the most daring idea of all, the possibility that the pyramid was never only a tomb, but a working system, a grand device built to channel forces not of technology, but of nature itself. The idea that the Great Pyramid might itself have been a machine has haunted scholars, engineers, and dreamers for centuries. It is a notion that sits at the crossroads of myth and science, both alluring and perilous. To imagine the pyramid not merely as a monument or tomb, but as a device, a structure that performs a function, is to challenge every assumption we hold about ancient intent. Yet, every few generations, this idea resurfaces, rekindled by each new discovery of voids, shafts, and unexplained features hidden deep within the stone. The roots of this speculation stretch back to the 19th century, when explorers first mapped the pyramid's internal passages. Some believed the geometry encoded mathematical constants far beyond known Egyptian knowledge. Others claimed it resonated with the Earth itself. Later, in the 20th century, when electrical technology became the language of progress, the same imagination transformed the pyramid into a giant energy collector or generator. Books and theories flourished, describing resonant chambers, hydrogen reactions, and Earth frequency amplifiers. Each version was different, but all shared a single intuition that the pyramid was doing something. Modern science, however, approaches the question differently. Physicists, engineers, and archaeologists look for measurable functions, mechanical, structural, or acoustic, that could justify the machine analogy without invoking the supernatural. They ask, could the pyramid have used natural forces, such as vibration, gravity, or fluid pressure, as part of its design? Could its geometry have channeled energy in ways that served practical or symbolic purposes? These questions hover at the boundary between physics and archaeology, inviting both rigor and imagination. Some of the earliest machine interpretations came from observing the pyramid's proportions. The Great Pyramid's dimensions embody ratios that appear in nature, the golden ratio, pi, and harmonic intervals found in waveforms. These coincidences suggest that the builders understood geometry not only as measurement, but as resonance, a harmony between form and frequency. The pyramid's slope, just over 51 degrees, creates a specific relationship between height and base that mirrors natural patterns of energy distribution from planetary orbits to atomic structure. Whether this was intentional or symbolic remains uncertain, but the correspondence is undeniable. Acoustic studies inside the pyramid have revealed that certain chambers amplify sound at distinct frequencies. When tones near 120 Hz are generated in the king's chamber, standing waves form that cause the granite walls to vibrate subtly. The sound lingers, sustained by the chamber's perfect dimensions and smooth surfaces. Some researchers speculate that this resonance may have had ritual significance, perhaps used during ceremonies involving chanting or music. The Egyptians saw sound as a creative force. The spoken word of the gods brought the world into being. In that sense, a chamber designed to resonate could be seen as a literal echo of creation. Still, the leap from acoustics to machinery is enormous. Most scientists view the pyramid's resonant properties as an incidental result of its geometry, rather than evidence of intentional engineering for energy. Yet, the fascination persists because the structure behaves like a natural resonator, capable of concentrating and sustaining vibration. Recent computational models have even shown that electromagnetic waves can focus within the pyramid's cavities, creating zones of enhanced energy density. The effect is purely physical, but its symbolism is potent, a stone mountain that gathers the invisible pulse of the earth. Another speculative idea involves water and pressure. Some have proposed that the pyramid's subterranean chamber once connected to underground aquifers. When the Nile flooded, water could have entered the lower passageways, compressing air and producing vibrations throughout the structure. This theory remains unproven and controversial, yet it reflects an ancient understanding that water, air, and sound were linked. The Egyptians worshipped these elements as aspects of balance. If any part of this system existed, it would make the pyramid not an engine in the modern sense, but a natural harmonizer, a structure tuned to the rhythms of the planet. Despite its allure, the machine hypothesis has no direct archaeological evidence. No copper wires, gears, or mechanisms have been found within the pyramid. The walls show no signs of heat or chemical reaction. What they reveal instead is an obsession with precision, alignment, and permanence. If the pyramid functions as a machine, its product is not energy, but stability. It channels forces not to move, but to remain immovable. In that sense, its mechanical perfection achieves a spiritual purpose, to outlast chaos, to resist time. Mainstream Egyptologists remind us that all such interpretations must remain grounded in context. The pyramid fits into a long tradition of mortuary architecture, evolving from simple mastabas to complex step pyramids and smooth-sided monuments. Each innovation served religious and symbolic goals rather than practical mechanics. To the ancient Egyptians, eternity was the ultimate function. The pyramid's perfection ensured the pharaoh's transformation into a god. Its energy was metaphysical, not mechanical. Yet, from a scientific perspective, the two are not mutually exclusive. Symbolic intent can coexist with physical effect. The builders may not have sought to generate power, but they understood how geometry, mass, and vibration could shape experience and meaning. What makes the pyramid so compelling is precisely this ambiguity. It blurs the boundary between purpose and performance. Even if its builders never conceived it as a machine, it behaves like one in many ways. It manages stress and weight with mathematical precision. It maintains temperature stability across millennia. It channels sound, air, and light in measurable patterns. It aligns perfectly with the cardinal directions, functioning as an astronomical reference point. These qualities make it an instrument, if not a machine, a device that translates natural laws into enduring form. Perhaps then the pyramid's true function lies not in harnessing external energy, but in demonstrating mastery of internal harmony. It is a structure that performs balance, converting disorder into symmetry, chaos into permanence. Its operation is time itself. The longer it endures, the more power it reveals, not in motion, but in stillness. The pyramid teaches that perfection is a form of energy. As physicists and archaeologists continue to explore its hidden chambers, the idea of the pyramid as a machine remains both provocative and poetic. Each new discovery of voids or density anomalies rekindles curiosity. Yet, no evidence suggests engines or lost technology. The pyramid's mystery endures precisely because it stands at the intersection of imagination and evidence, of myth and measurement. It invites us to ask not what it does, but what it means. In the end, perhaps the ancient builders did not intend to construct a machine in the mechanical sense. They built something greater, a structure that embodies the principles by which machines and all things operate, equilibrium, resonance, and continuity. The pyramid is not a generator of energy, but a generator of wonder. Its power is the awe it inspires, the questions it provokes, the balance it preserves between human ambition and cosmic law. The notion of the pyramid as a machine gains its greatest strength not from fantasy, but from the language of science itself. When physicists examine the pyramid, they see an object that behaves according to the same natural laws that govern the cosmos. It channels weight, pressure, and resonance in predictable ways. In this sense, it is already an engineered system, a mechanism of balance that operates on principles recognizable to modern physics. Its precision is the signature of intention, and intention is the first requirement of any machine. Inside the Great Pyramid, air and sound move with surprising clarity. Explorers who have spoken within its chambers describe the way their voices carry and return, as though the stone itself listens. In the king's chamber, a single word becomes an echoing chord, and footsteps fall like drums of eternity. Modern acoustic studies show that these effects are not accidental. The chamber's granite walls, polished and uniform, reflect sound almost perfectly, creating a resonance that amplifies certain frequencies. The sound waves bounce between the walls, floor and ceiling, forming standing waves that concentrate energy in specific points. The result is a natural amplifier, a space tuned to vibration. To the Egyptians, sound was sacred. Their creation myths describe the universe emerging from a single spoken word. To build a space that resonates is to recreate that moment of origin. The pyramid, in this view, becomes an instrument, a massive, silent lyre whose strings are made of air and stone. The pharaoh lying within was not merely entombed, but placed inside a cosmic resonator designed to carry his spirit into the eternal harmony of the stars. Such poetic imagery aligns with scientific fact. Resonance focuses energy, and focused energy transforms its medium. The builders may not have known these terms, but they knew their effects. Some researchers propose that the pyramid's design also interacts with the Earth's natural electromagnetic field. Its alignment with the cardinal points ensures that it captures and channels the planet's subtle forces symmetrically. Modern measurements have shown small but detectable variations in electric potential near the apex and base of the structure, likely caused by differences in air ionization and surface conductivity. While these effects are far too weak to imply electrical function, they illustrate that the pyramid does participate in the planet's energy landscape. In that sense, it is not a generator, but a mediator, harmonizing with the invisible currents that flow through the atmosphere and ground. There is also the possibility of hydraulic resonance. The subterranean chamber, carved deep into the bedrock, sits at a level once closer to the ancient water table. When floods or groundwater shifts occurred, the pressure changes could have sent subtle vibrations upward through the structure. The narrow ascending and descending passages would have acted as conduits, transmitting those vibrations like the pipes of an organ. In a purely physical sense, the pyramid may have been alive with movement invisible to the eye. The sound of water beneath, the whisper of wind above, the pulse of heat and cold through its stone. All these formed a quiet symphony that has continued for millennia. Yet, it is important to separate observation from speculation. The measurable properties of the pyramid, its acoustic behavior, its structural harmony, its electromagnetic alignment, are real. The interpretation of purpose, however, remains open. Did the Egyptians design these features deliberately, or are they the incidental byproducts of perfect geometry? Most Egyptologists lean toward the latter, but for those who look deeper, intent and outcome are intertwined. A culture that saw the cosmos as a single, interconnected system would have understood that every line drawn in stone echoed the patterns of the heavens. To them, structure was meaning. To think of the pyramid as a machine in this context is not to imagine pistons or wires, but to recognize it as an engine of transformation. It converts labor into permanence, faith into form, time into stillness. It takes the energy of countless human lives and focuses it into one enduring act of creation. Each block represents work, breath, heartbeat, billions of moments crystallized in limestone. The pyramid functions because it unites those forces into a single, unbroken geometry. That is not metaphor. It is physics written in human devotion. Even its orientation to the stars reveals an underlying function. The shafts from the king's chamber point toward Orion and Thuban, the axis around which the heavens appeared to turn. These were not random choices. The Egyptians believed that the soul of the pharaoh would rise to join the imperishable stars that never set. By aligning the pyramid with those celestial coordinates, they anchored the structure to eternity. In this sense, it operates as a navigational device, not across space, but across existence itself. The pyramid is a map of the soul's ascent, a cosmic machine for resurrection. Modern researchers often resist such poetic interpretations, yet even in their data, the language of wonder persists. They speak of resonance modes, density gradients, stress harmonics, phrases that echo music more than mechanics. The pyramid's perfection forces scientists to speak with reverence, whether they intend to or not. Every new measurement uncovers another layer of symmetry, another refinement of balance. It is as if the monument continually adjusts to our gaze, revealing exactly enough to sustain curiosity, while hiding the rest behind its timeless silence. The more we learn, the more the pyramid resists reduction. It is not simply architecture or mathematics or faith, but all of these combined into one expression of cosmic understanding. When viewed through this lens, the idea of it being a machine ceases to sound strange. The pyramid is the world's oldest functioning system, designed to manipulate not electricity or motion, but perception itself. It transforms our sense of time and possibility. Standing before it, the mind struggles to grasp its scale, and in that struggle it changes. That transformation, the awakening of wonder, is its true operation. Even today, the pyramid continues to perform. It draws energy from the human imagination, compelling every generation to measure, scan, and question. The detectors that peer through its stone are part of the same mechanism. We are still participants in its design, still feeding its function through curiosity. The pyramid is not inert, it is interactive, a dialogue between past and present, between builders and discoverers. In that sense, it fulfills its purpose perfectly. It endures not only as stone, but as mystery, always alive in the minds that seek to understand it. To look upon the Great Pyramid as a machine is to confront the boundary between science and myth, where explanation meets reverence. Every generation that studies it brings new tools and new interpretations, yet the essence remains unchanged. The structure does not simply exist, it behaves. It interacts with gravity, heat, light, and vibration, as though it were an instrument tuned to the universe itself. Its angles catch the sunrise with precision. Its mass absorbs and releases warmth through the day and night in cycles that mirror the breath of the desert. Nothing about it is static. It lives in equilibrium. If the pyramid is a machine, its purpose may be eternal rather than functional. Modern engines serve temporary ends. They move, they consume, they wear down. The pyramid's purpose seems opposite. It is an engine of stillness, built not to perform work, but to endure beyond it. Its energy is conservation, not consumption. Over thousands of years, it has outlasted empires, climates, and even continents in their shifting forms. That alone is a feat no human invention has equaled. If the builders meant to create an object that transcends decay, they succeeded with perfection. When physicists model the pyramid's mass distribution, they find that it is astonishingly stable. Its center of gravity sits almost exactly at 1/3 of its height, ensuring perfect balance on its base. Its shape naturally resists erosion from wind and sand, deflecting force downward into the plateau. Thermal scans reveal how its temperature lags behind the environment, cooling and heating with such gradual rhythm that it remains internally constant while the desert swings between scorching day and freezing night. In mechanical terms, it regulates itself like a living organism. This self-regulation extends to the flow of air through its narrow passages. Though sealed for millennia, these channels maintain stable humidity levels, preventing condensation that could damage the stone. Whether by design or accident, the pyramid preserves itself. It behaves as a closed system that dissipates stress, equalizes temperature, and protects its own interior from the chaos of the outside world. What other object built by human hands can claim such autonomy? The Great Pyramid does not require repair. It sustains itself through geometry alone. To imagine that this was accidental strains belief. The builders knew how to balance mass and temperature, how to align form with the stars, how to bind the living and the eternal through stone. They may not have spoken the language of thermodynamics or resonance, yet they understood those laws in practice. Their technology was observation perfected into art. The pyramid stands as the ultimate experiment, a proof of concept showing that harmony itself can be engineered. In that sense, it is a prototype of every system that seeks balance, from planetary orbits to modern architecture. Some modern thinkers see the pyramid as an early expression of what we now call systems theory, the study of how parts interact to form a stable whole. The pyramid embodies this idea in material form. Its structure is a network of interdependent forces: weight, friction, airflow, temperature, all working in concert to maintain equilibrium. When one variable shifts, others compensate. The monument behaves like a feedback loop, constantly adjusting within the limits set by its own perfection. It is not a static pile of stones. It is an ongoing equation solving itself through time. Even its visual impact plays a role in its operation. The pyramid's vast surfaces alter perception of scale, forcing the human mind to grapple with immensity. Standing before it, one loses the sense of proportion. This psychological effect was not accidental. Ancient inscriptions describe the pyramid as a horizon, the meeting point of earth and sky. To look at it was to experience the merging of the finite and the infinite. In this way, it becomes a mental machine, engineered to shift consciousness. Its function is awe. There is beauty in the possibility that the Egyptians achieved this synthesis without separating science from spirit. For them, the laws of nature were the laws of divinity. The pyramid was not built to exploit those laws, but to embody them. It was both symbol and mechanism, prayer and proof. Its perfection demonstrates that knowledge and faith can coexist, not as opposites, but as reflections of the same truth. Every stone placed upon another was an act of worship through engineering. When we study it today with particle detectors and computer models, we are continuing that same act of reverence through different tools. The muons that pass through its mass, the radar waves that map its hidden chambers, the lasers that trace its alignment, all reveal not secrets of lost technology, but confirmations of enduring genius. Each measurement brings us closer to understanding how the pyramid thinks, not in the sense of consciousness, but in the sense of design. Its logic is built into the arrangement of its matter, a silent intelligence encoded in limestone. If there is power in the pyramid, it is not mystical or electrical. It is informational. It teaches by existing. It shows that stability is an achievable miracle, that endurance can be constructed, that harmony is measurable. It functions as a message across time, demonstrating what happens when knowledge, faith, and patience are combined without division. The pyramid does not merely symbolize eternity, it operates as eternity made visible. This is why the idea of it as a machine persists. Deep within its geometry lies a truth that modern science continues to chase: the unity of physical law and human purpose. The pyramid, in its silence, performs that unity every day. Whether seen as monument or mechanism, its power remains the same. It does not generate light or motion, it generates understanding. It converts observation into awe, science into meaning. And so, after centuries of speculation, the radical idea resolves into simplicity. The Great Pyramid is not a generator, nor a transmitter, nor an ancient engine lost to time. It is something far more profound, a demonstration that the universe itself can be written in stone. In that way, it is the first and greatest machine of all, one that still runs perfectly, powered by gravity, time, and the enduring wonder of those who gaze upon it. The discovery of voids within the Great Pyramid reignited a question as old as the monument itself. Why would the builders leave spaces inside what seems to be the most meticulously solid structure ever conceived? The ancient Egyptians were masters of precision, their engineering deliberate and exacting. Every chamber, every passage, every angle served a purpose, yet Muons scans and infrared imaging have revealed great cavities hidden within the stone, spaces so large and symmetrical that coincidence is unthinkable. To understand them, we must look beyond fantasy and into the subtle mechanics of ancient design. The first and most grounded explanation is structural. Stone, though seemingly unyielding, behaves like any other material under immense weight. It deforms, cracks, and shifts. The Great Pyramid weighs nearly 6 million tons. Without internal voids to relieve pressure, the chambers below would have collapsed long ago. The ancient builders solved this by inserting empty spaces strategically above key rooms. The best-known example is the series of relieving chambers above the king's chamber. 5 layers of massive granite slabs, separated by narrow gaps, distribute the weight of the pyramid's upper stones outward instead of downward. This simple yet brilliant design allows the chamber to remain intact under thousands of tons of pressure. It is possible that the newly discovered voids function in a similar way. Their size and alignment suggest they could act as massive cushions of air and stone, redirecting structural stress. Modern engineers often use this principle in skyscrapers and bridges, creating hollow zones that absorb vibration and distribute load. In this light, the Great Pyramid was not merely a static object, but an active system, a structure that managed internal force as if it were breathing in slow motion over millennia. Yet, not all voids align neatly with stress points. Some lie in regions where the pressure is already balanced, raising questions about their purpose. One idea is that they are remnants of the construction process, spaces once used as passageways or staging areas, later sealed when their work was complete. If the internal ramp theory is correct, these voids could be the ghostly remains of that ancient machinery, a network of corridors through which stones once ascended toward the summit. When the final casing was placed, the ramps may have been filled partially or left hollow, their entrances hidden forever. Another theory considers the role of ventilation. The narrow shafts extending from the king's and queen's chambers toward the pyramid's outer faces have long puzzled researchers. Originally thought to be air passages, they are too small and steep to have provided practical airflow for workers or occupants. Their orientation, however, aligns with specific stars associated with rebirth and eternity. It is possible that the builders used air and star interchangeably, physical openings serving symbolic purposes. The voids might belong to this same logic. They could be channels for balance, not of air but of meaning, designed to connect the earthly structure with the cosmic order. The Egyptians were not only engineers but philosophers of geometry. To them, balance was divine. The pyramid's internal spaces may therefore serve as instruments of harmony, ensuring that the monument's mass remained in equilibrium both physically and spiritually. Just as music requires silence between notes, architecture may require emptiness within form. The voids, in this interpretation, are the silent intervals that make the pyramid's geometry sing. There is also the possibility that some cavities were built for ritual or symbolic function. The Egyptians believed that death was not an end but a transformation, and that the pharaoh's spirit would ascend through stages represented by the pyramid's interior. The known chambers trace a vertical journey, from the subterranean chamber, linked to the underworld, to the queen's chamber, representing rebirth, to the king's chamber, symbolizing ascension. If the newly discovered void lies above the grand gallery, it may represent the final stage, a chamber of passage from Earth to the eternal stars. Such symbolism fits perfectly within the Egyptian cosmology, even if no human ever entered the space. Its presence alone would fulfill the ritual of ascent. Some scientists propose that these voids serve to manage more subtle forces. Studies of thermal behavior show that cavities can regulate temperature by trapping air that expands and contracts with the desert's daily cycle. This natural rhythm stabilizes the surrounding stone, preventing cracks caused by sudden heat shifts. Over thousands of years, such regulation could be vital to the monument's survival. If this is correct, the voids act as thermal lungs, quietly moderating the pyramid's internal environment. Once again, the builders appear to have turned natural law into architecture. Still, mystery lingers. The Muon data suggests that the big void above the Grand Gallery is enormous, 30 meters long, with a cross-section comparable to the gallery itself. No one can yet explain why such a massive space was left completely sealed. If it was simply a relieving chamber, why so large? If a construction gap, why so carefully aligned? The symmetry implies deliberate design. Even if the void was not meant to be entered, its existence was necessary to the pyramid's logic. Perhaps the builders considered emptiness itself to be a form of perfection, a mirror of the unseen order they sought to capture in stone. Modern architects studying the pyramid often describe it as a system of counterbalances. Every mass is answered by a void, every force by a relief. This duality echoes principles found in nature, the relationship between gravity and lift, tension and compression, matter and vacuum. The Great Pyramid may thus embody a physical metaphor of the universe itself, a solid form built around absence, a monument that endures precisely because of its internal emptiness. To the Egyptians, emptiness was not nothingness, it was potential. In their language, the word for void often carried the meaning of creation, the primordial sea from which the world emerged. If the pyramid mirrors the cosmos, then its hidden cavities may represent that creative void, the space from which divine order arises. In that sense, these chambers are not defects or oversights, but essential elements of a sacred machine, balancing substance and absence to sustain harmony. Each new scan reveals that the Great Pyramid is less a tomb and more a dialogue between matter and space. Its architecture operates like a vast equation of opposites, where weight meets lightness, density meets air, presence meets emptiness. The voids are the unknown variables in that equation, unseen but indispensable. To discover their function is to glimpse the mind of their creators, who understood that perfection is not found in fullness, but in balance. The discovery of these voids has changed the way scientists think about the Great Pyramid. Once imagined as a uniform stack of stone blocks, it is now seen as an intricate organism of solid and hollow, its integrity maintained through contrast. The cavities within it are not flaws or accidents, but part of an ancient conversation between pressure and release. In every material system, even in the human body, emptiness plays a role. The Egyptians appear to have known this intuitively. Their engineers carved space as carefully as they placed stone. When the first relieving chambers above the king's chamber were discovered in the 19th century, they astonished the world. 5 successive levels of granite beams, each separated by a small void, proved that the builders understood how to control stress. What makes this design extraordinary is its anticipation of modern structural principles. By interposing empty layers between weight-bearing stones, the builders transformed crushing vertical pressure into distributed lateral force. Without those cavities, the ceiling would have collapsed long ago. In this simple design lies one of the most advanced insights in engineering, the realization that absence can bear weight. The newly found voids may apply this same logic on a grander scale. Some of the Muon-imaged cavities lie directly above stress points created by the Grand Gallery's high corridor, where the slope and open volume concentrate tension. If the void above it mirrors the gallery's shape, it could serve as a vast balancing chamber, dispersing that force through the upper layers. To modern architects, this would make perfect sense. The pyramid's apparent solidity would be a carefully controlled illusion. Its strength depends not on mass alone, but on how that mass is distributed around nothingness. There are, however, anomalies that defy this explanation. Certain cavities, detected near the pyramid's flanks, do not correspond to known stresses. Some appear oddly placed, like silent punctuation marks in a text we have not yet learned to read. The more data physicists collect, the more they realize that the pyramid's internal structure may not be symmetrical. These asymmetries hint at a more complex purpose. Perhaps the voids were part of a staged construction process, filled or sealed in deliberate sequence. Each gap could mark a temporary scaffold or balancing volume used during specific phases of building. When the final stones were laid, the internal architecture would have stabilized, leaving behind hidden pockets of emptiness. the preserved footprints of the pyramid's own creation. Archaeologists exploring nearby pyramids have found supporting evidence. In the Pyramid of Sneferu at Dahshur, internal chambers and angled voids appear to have been used to correct structural problems that arose during construction. The builders adjusted the slope midway, reinforcing weak zones with cavities that relieved pressure. It seems that the idea of engineering through emptiness was not unique to Khufu's pyramid, but part of a broader architectural tradition. Giza represents the perfection of that principle, the moment when void and form reached equilibrium so precise that the structure has survived thousands of years without collapse. Beyond their physical role, the voids also carry symbolic meaning. The Egyptians believed that the universe was born from an infinite sea of potential, the Nun, out of which the first mound of creation emerged. The pyramid, rising from the desert like that primeval mound, reflects this myth in stone. The empty spaces within could represent the waters of chaos that still lie beneath the order of creation, a silent reminder that stability exists only because it floats on emptiness. To walk inside the pyramid, to ascend its narrow shafts and chambers, is to move through the same metaphysical journey from chaos to cosmos. Even the air that circulates through its passages can be seen as the breath of that transformation. There is also the question of resonance. Some physicists suggest that the cavities might alter how the pyramid vibrates when struck by sound or seismic waves. By adjusting the size and position of internal voids, the builders could have tuned the monument like a vast instrument, ensuring that vibrations dissipated harmlessly rather than concentrating into destructive frequencies. This concept, though modern in phrasing, fits perfectly with ancient symbolism. To the Egyptians, harmony was not only aesthetic, it was structural. They may have designed the pyramid to sing in perfect silence, its internal geometry maintaining equilibrium through resonance beyond hearing. Infrared thermography offers a glimpse of how these voids interact with the desert environment. Certain zones of the pyramid heat and cool at different rates, suggesting pockets of air or less dense material beneath the surface. These temperature variations might have been accidental consequences of construction, but they may also indicate deliberate thermal management. If air trapped within the voids expands during the heat of day and contracts at night, the resulting micro-movements could help relieve internal stress. Over centuries, such effects could be the difference between endurance and collapse. What makes all this so remarkable is how the builders achieved these outcomes without modern calculation. They worked by observation, intuition, and scale models, testing how stone behaved under weight and temperature. They must have known that space itself could be shaped as precisely as matter. In their hands, voids became tools. Each cavity was not an absence but an element of structure, as vital as the block surrounding it. The Great Pyramid thus stands as the oldest known example of dynamic architecture, a system designed to interact continuously with its environment. Some have wondered whether these voids might also conceal the practical remains of construction, hidden chambers storing tools, ropes, or ceremonial objects sealed when the work ended. While no direct evidence supports this, the idea lingers because of the sheer size of the uncharted spaces. The big void, stretching for 30 meters, could easily accommodate entire chambers within it, but so far the data show no sign of metal or wood, only the signature of emptiness. It seems the void's function was not to hide, but to sustain. To modern engineers, the pyramid's internal emptiness is a revelation. It demonstrates that the greatest strength can arise not from unbroken solidity, but from carefully balanced hollowness. This principle, used today in bridges, domes, and aircraft, is the very foundation of advanced engineering. The Egyptians discovered it first, translating intuition into geometry without a single written formula. The Great Pyramid is thus not only the ancestor of architecture, but the prototype of structural science. Its voids are the first expressions of negative space as function, not failure. The more we learn, the clearer it becomes that these chambers are not random. They are the quiet machinery of endurance. They absorb force, balance mass, and moderate temperature, all while embodying the metaphysical principles of balance and creation. In them lies the key to the pyramid's power, the understanding that what is absent can be as vital as what is present. every generation of researchers who studies the Great Pyramid eventually reaches the same conclusion. The voids within it are neither mistakes nor mysteries left by chance. They are part of a hidden logic, a system of emptiness woven through the stone, like threads of silence through music. To understand them, one must accept that the pyramid is not merely a static monument, but a living design, a dialogue between matter and space. Each chamber and corridor participates in this conversation. What the builders achieved was not the elimination of emptiness, but its orchestration. The most revealing clue lies in how the pyramid behaves under time. Over 4,500 years, its structure has endured earthquakes, shifting foundations, and the erosion of casing stones. Yet, the inner geometry remains intact. Modern finite element simulations, digital models of how stress moves through material, show that the load distribution inside the pyramid flows around its cavities in graceful arcs. Where solid mass would crack, the presence of voids allows energy to circulate and dissipate. It is as though the builders anticipated the natural decay of matter and designed the monument to heal itself through space. The pyramid is not a monolith resisting destruction, it is a structure that absorbs and transforms it. This principle finds echoes across Egyptian philosophy. In their art and myth, balance was the highest law, expressed in the goddess Maat, who embodied truth and order. The pyramid is Maat made visible. Its symmetry and its hidden hollows manifest the same dualism, the coexistence of weight and lightness, form and void, being and non-being. The builders understood that endurance requires opposition. Stone alone cannot stand against time. It needs the breath of emptiness to keep it alive. Some scientists now suspect that smaller voids, undetectable by current instruments, may permeate much of the pyramid. These microscopic gaps between blocks would act like tiny shock absorbers, allowing the structure to expand and contract with temperature and seismic change. If true, the pyramid's stability results not only from its size but from the subtle flexibility of its design. The builders did not seek rigidity, they sought resilience. They engineered the world's largest structure to behave like a living thing, solid yet adaptable, eternal yet responsive. This notion challenges the way modern people define technology. We associate machines with motion, with energy converted into work. But the pyramid operates on another scale. Its machine is geological time. Its energy is equilibrium. The voids within it function as regulators, keeping the balance between pressure and release, between the heat of the sun and the coolness of the night. The pyramid endures because it breathes through its emptiness, in cycles so slow that only the universe itself can measure them. To the ancient Egyptians, such a design would have carried deep symbolic resonance. The voids might represent the cosmic spaces between stars, the invisible corridors through which the pharaoh's soul would travel toward the heavens. The Grand Gallery's steep incline, leading upward to the king's chamber, already suggests ascent. The void above it could complete that journey, a hidden chamber of transformation where the mortal becomes divine. It would not need to be entered, for its purpose was metaphysical. Its mere existence fulfilled the cosmic diagram etched into the pyramid's geometry. Some archaeologists find traces of this idea in the pyramid texts, the oldest religious writings known. These inscriptions speak of the king rising through the air shafts as a falcon of light, passing through the gates of the sky to join the gods. The shafts themselves are physical manifestations of that myth. The voids could be extensions of the same ritual architecture, spaces of passage not for bodies, but for essence. If the pyramid was built as a machine of eternity, these cavities are its conduits, unseen but necessary for the cycle of rebirth it enacts. The physics and the symbolism converge on a single truth. Emptiness is not absence, it is potential energy, waiting to be activated by perception. The pyramid's voids remind us that what we cannot see may be more important than what we can. They are the hidden variables in the equation of eternity, the unseen mechanics of permanence. Without them, the pyramid would be just a mountain of stone, destined to crumble like all mountains. With them, it becomes something different, a balanced system where material and void sustain one another forever. Even the methods we use to detect these voids echo the principle they embody. Muons, particles born from cosmic rays, pass through the pyramid, mapping its density through absence. Where fewer muons are absorbed, we find hollowness. Thus, the universe itself reveals emptiness through what is missing. The pyramid is studied by the same forces that created it: energy, matter, and the spaces between. It is a dialogue between cosmic particles and human intention, between stars and stone. As our instruments grow more sensitive, more voids will likely emerge from the data, each demanding interpretation. Some will prove structural, others symbolic, and perhaps a few will defy both categories. Yet the lesson remains constant. The Egyptians mastered a form of engineering that merged physical necessity with spiritual expression. They built a monument that is both solid and hollow, both science and scripture. Its power lies not in hidden machinery, but in its understanding of balance, the realization that creation depends as much on what is removed as on what is placed. In the end, the voids are the heart of the pyramid's endurance. They are the pauses that allow the music of its structure to resonate across time. They are the invisible spaces where gravity meets grace, where weight turns to silence. If we could stand inside one, we might hear not emptiness, but the faint hum of eternity itself, a resonance too deep for human ears, echoing through the stone as it has since the day the last block was set. When physicists turned their cosmic eyes toward the Great Pyramid, what they found was not the solid mountain of limestone long imagined, but a far more intricate composition of densities and shadows. The Muons, born high in the atmosphere from collisions of cosmic rays with atomic particles, became our celestial messengers, carrying through the stone the story of what lies hidden within. Each muon passes through matter at nearly the speed of light, slowed only slightly by atomic mass, and in that deceleration they whisper the secrets of density. By measuring how many of them make it through, scientists can reconstruct a map of what is solid, what is hollow, and what may be filled with something in between. As the data accumulated, patterns began to emerge that no one could have predicted. Some regions of the pyramid appeared less dense than their surrounding stone, while others showed surprising concentration. These were not the great open voids previously announced, but subtle variations, gradients of matter that suggested the pyramid was not uniform in its construction. The traditional image of endless limestone blocks, perfectly stacked, was suddenly replaced by a vision of complexity, zones of lighter material, layers of compacted fill, and perhaps even inclusions of substances we have yet to identify. The pyramid, long considered the epitome of simplicity, revealed itself to be nuanced, almost organic in its internal structure. Muon radiography, unlike X-ray or radar, does not see with light or sound. It sees through interaction. The denser the material, the fewer muons escape. When detectors placed around the pyramid registered unexpected brightness in certain zones, physicists realized they were glimpsing areas of lower density. Some of these aligned with known chambers, but others did not. The images showed pockets of stone that behaved as though they were less compact or perhaps composed of different materials altogether. It was as if the pyramid had geological veins, regions of variable mass woven through its core. This discovery ignited a debate that reached far beyond Egyptology. Were these low-density zones the result of ancient engineering techniques, intentional features that improved stability? Or were they simply imperfections, signs of human improvisation on a scale too vast to control? Some researchers proposed that the builders used fill material in upper regions to reduce overall load, perhaps a mixture of sand, gravel, and gypsum mortar. Others argued that these could be remnants of construction ramps or internal scaffolding, later sealed as the structure rose. The scans alone could not decide. Each possibility painted a different portrait of ancient genius, one emphasizing calculated efficiency, the other the power of adaptation. Infrared thermography added another dimension to the mystery. When scientists measured the surface temperature of the pyramid at different times of day, they noticed certain blocks cooled and heated at different rates. These thermal anomalies corresponded closely with the density variations detected by muons. The implication was that internal cavities or lighter materials were influencing heat flow through the stone. What we see from outside, the shimmering gold of sunrise upon ancient limestone, is a faint signature of hidden architecture within. The pyramid breathes thermally, exhaling warmth at night and absorbing it by day, and within that rhythm lie the traces of its unseen composition. Some studies suggested even stranger possibilities. Researchers working with improved muon detectors noticed scattering effects, patterns inconsistent with simple voids or uniform stone. These might indicate inclusions of different materials, perhaps even wooden reinforcements or rubble infill. Though wood rarely survives millennia, traces of it have been found in other Egyptian structures, preserved in arid microclimates. Could the Great Pyramid contain fragments of the tools and scaffolding used to raise it, sealed forever in its interior? If so, it would mean that part of the pyramid's mystery is literally entombed within it, the ghosts of its own making fossilized in stone. Modern projects such as the SciDep Muon Radiography Initiative have begun designing detectors capable of resolution 100 times finer than those used in 2017. These instruments, derived from particle physics experiments at underground observatories, can track the angular deviation of muons as they scatter through matter. By measuring not only how many pass through but also how they change direction, scientists can differentiate between air, limestone, and even variations in mineral content. It is a new kind of archaeology, one that peers into the past using particles that have themselves crossed the galaxy. Preliminary data from these improved sensors suggest that some of the lower density regions might not be empty at all. Instead, they could contain a mixture of smaller stones and binding materials deliberately arranged to manage stress. This technique, if confirmed, would demonstrate that the Egyptians understood the principle of gradient density, varying the mass of material to achieve stability. In modern engineering, this method is used in composite structures and aerospace design. The thought that such an approach might have been used 4,500 years ago reframes our understanding of ancient science entirely. There is also evidence of density anomalies at the interface between the pyramid's core and its outer casing. Some of these may mark ancient repair efforts, where damaged areas were reinforced with different stone types after construction. Others could represent natural variation in the quarry materials. Yet, a few anomalies remain inexplicable, zones where density drops sharply without visible seams or cracks. These could be hidden voids too small to detect directly, or perhaps cavities filled with sand or crushed stone. In either case, they show that the pyramid's interior is not monolithic but layered in ways we are only beginning to perceive. The implications reach beyond architecture. Density variations influence how the pyramid interacts with environmental forces, temperature, vibration, even seismic activity. It may be that these anomalies are not flaws but adaptations, features that allow the structure to endure by diffusing stress through uneven composition. If true, the pyramid operates on the same principle as living bone, which strengthens along lines of tension and lightens where flexibility is needed. The monument becomes, in this view, not a dead pile of stone, but a self-regulating organism, an ancient example of biomimicry before the concept had a name. As technology advances, scientists hope to combine muon imaging with neutron spectroscopy and ground-penetrating radar to build a full three-dimensional model of the pyramid's interior composition. Such a map would reveal not only its chambers but its gradients of matter, its internal ecology of weight and void. It would allow engineers to simulate how the structure breathes and shifts through the centuries, how the heat of day ripples through its mass, how the vibration of footsteps at its base travels upward through the ancient stone. For the first time, we might witness the pyramid not as an artifact, but as a living system of matter and geometry. And yet, even as instruments grow sharper, one truth remains constant. The pyramid guards its essence through silence. Every discovery opens a new question. Every image deepens the sense of deliberate mystery. The density anomalies may one day be measured to the last gram per cubic centimeter, but their meaning will still belong partly to imagination. Were they pragmatic choices or sacred symbolism, an attempt to balance physical and metaphysical forces within the same monument? The answer may lie in both realms at once. Perhaps the voids and gradients, the denser cores and lighter seams, all serve a single function: to preserve equilibrium. The pyramid endures because it knows how to distribute imperfection. Its power lies in its ability to contain both matter and uncertainty, both calculation and mystery. Even now, as Muons whisper their findings into detectors buried in the desert sand, the pyramid reminds us that perfection is not uniformity but harmony, the coexistence of density and emptiness in a design that outlasts time itself. The Great Pyramid stands not only as a monument of stone, but as a mirror of our own divisions. It reflects the fault lines between disciplines, between those who see the past through the tools of archaeology and those who approach it through the equations of physics. Every discovery that deepens its mystery seems to widen that divide. When the Big Void was first announced in 2017, the world reacted with awe, but among the experts, reactions were mixed. For physicists, it was proof of the power of modern technology to peer through time. For Egyptologists, it was a reminder that data without context can mislead. Both sides sought truth, but their definitions of truth were different. Archaeologists see the pyramid as part of a cultural continuum. It is the culmination of architectural evolution rooted in ritual, religion, and royal authority. For them, every chamber, every block, every inscription belongs to a social story. The pyramid was not built by mathematicians in isolation, but by a civilization guided by belief. Meaning must be excavated, not calculated. A void detected by muons is not automatically a chamber. It could be an accidental space, a structural gap, or even an illusion caused by uneven density. Egyptologists insist that no scientific image can replace the slow, careful process of physical investigation. The past, they argue, cannot be understood by senses alone. Physicists, on the other hand, view the pyramid as a physical system, a structure that can be analysed through measurable properties. To them, density, geometry, and resonance speak a universal language, one that transcends human culture. Their instruments detect what eyes cannot see, and their equations reveal patterns invisible to history. When they speak of energy distribution or stress diffusion, they are describing objective phenomena that exist whether or not anyone interprets them symbolically. For these scientists, the pyramid is not a text to be read, but a mechanism to be understood. This difference of perspective is not new. It echoes the ancient divide between the humanities and the sciences, between interpretation and experimentation. The pyramid sits precisely at the crossroads of those worlds. It is both artifact and equation, both message and machine. The conflict arises when one side claims completeness. Physicists sometimes treat data as final truth, while archaeologists fear that such claims erase the cultural complexity that gave rise to the structure. In truth, neither view is sufficient on its own. The tension is made worse by the politics of access. Excavation within the Great Pyramid is tightly controlled by Egypt's Ministry of Antiquities. The structure is too fragile, too sacred, and too central to national heritage for invasive exploration. Scientists working on scanning projects must operate under restrictions that prevent drilling, cutting, or even inserting probes into narrow passages. For physicists used to controlled, laboratory environments, these limitations are frustrating, but for Egyptologists, they are essential. Each block carries irreplaceable context, and one careless act could destroy evidence that has survived 4 millennia. Thus, every collaboration must balance curiosity with preservation, ambition with restraint. These competing priorities sometimes play out publicly. When the Scan Pyramids project announced the discovery of the Big Void, headlines around the world proclaimed the finding of a hidden chamber. Egyptologists objected immediately, pointing out that the word chamber implies function, not just space. A void might be structural, not ceremonial. To name it otherwise risks misleading the public and fueling pseudoscience. The physicists countered that they had simply described what their detectors measured, an anomaly in density, not an interpretation. But the media craved mystery, and mystery obeys its own gravity. In that moment, science and story collided, and the pyramid absorbed both. The problem is not that one side is wrong, but that both are incomplete. Egyptologists understand the pyramid's cultural context, the religious texts, the funerary practices, the evolution from the Step Pyramid of Giza to Khufu's masterpiece. But they often underestimate the sophistication of ancient engineering. The builders of Giza were not merely ritualists, they were experimenters who learned from failure and adjusted designs based on observation. Conversely, engineers and physicists sometimes overlook the symbolic architecture underlying every decision. The pyramid was not designed for efficiency alone. Its geometry expresses cosmic order, aligning the pharaoh's body with the stars and his soul with eternity. Each angle is both function and metaphor. There are moments, however, when these two worlds find common ground. The analysis of stress relief in the king's chamber, for instance, shows both practical and symbolic reasoning. The granite beams distribute weight, but they also elevate the chamber into a sanctified zone, the heart of the pyramid's metaphysical machinery. Similarly, the alignment with true north serves astronomical precision and spiritual purpose simultaneously. When both disciplines cooperate, the pyramid reveals its true nature, not a riddle to be solved, but a symphony to be interpreted. The need for cooperation has grown urgent as technology advances. Every new scan produces terabytes of data, maps of density, temperature, and electromagnetic reflection. Without archaeological interpretation, these numbers remain abstract. Without scientific validation, interpretations drift towards speculation. The most productive teams today include physicists, architects, and Egyptologists working side by side, translating between equations and hieroglyphs. This synthesis mirrors the unity the pyramid itself embodies, a structure where different forces balance into harmony. But the division also stems from deeper questions about what we seek to know. Engineers look for how, archaeologists look for why. The first asks by what means the stones were lifted. The second asks to what end. Both are necessary, yet their languages diverge. When a physicist says that a void relieves stress, an Egyptologist might reply that it relieves the burden of eternity, echoing religious belief. Neither is wrong, both speak truths of different domains. The challenge is to translate without losing meaning. In recent years, some have called for a new discipline altogether, a science of ancient systems that merges empirical analysis with cultural interpretation. The pyramid would be its ultimate test case. By studying how its physical structure expresses abstract principles, researchers could bridge the gap between matter and meaning. Such an approach might even inform modern design, teaching architects how to build structures that endure not only physically but symbolically. The Great Pyramid, after all, was built to last forever, and so far it has succeeded. The history of misunderstanding between Egyptologists and engineers is itself a reflection of the pyramid's dual nature. It is both art and science, both stone and thought. To study it requires humility before both physics and philosophy. The true power of the pyramid lies not in secrets hidden within, but in its ability to unite opposites, ancient and modern, measurable and mystical, practical and eternal. It stands as the first collaboration between human imagination and the laws of the universe. In the end, the division may not be a problem to solve, but a lesson to learn. The pyramid teaches that knowledge itself must be built like stone upon stone, balanced by emptiness, joined by purpose. Engineers and archaeologists alike are heirs to the same legacy, the quest to understand how humans once shaped time into form. Perhaps the day will come when their perspectives align as perfectly as the pyramid's corners with the stars. Only then will we see the monument for what it truly is, not a puzzle to be conquered, but a dialogue to be continued through every generation that dares to look up at its eternal geometry. Across the windswept plateau of Giza, the three Great Pyramids rise like frozen waves of time. Their forms are ancient, yet their presence feels alive, charged with a quiet power that has endured through more than 4.5 millennia. For centuries, people have wondered what force built them and what secret energy sustains their dominion over the desert horizon. Some have spoken of lost technologies or cosmic transmissions, others of divine geometry or celestial alignment. Yet the deeper we look, the more it becomes clear that the power of the pyramids is not something that can be measured in volts or vibrations. It is something far greater and far simpler, written into the very laws of matter and mind. When modern physicists speak of energy, they mean the capacity to do work, to cause change in a system. But there is another kind of power, the power of endurance, of order, of permanence against decay. The Great Pyramid harnesses this second kind. Its energy is the stability of geometry, the precision of alignment, the perfect negotiation between weight and void. Every block, every joint, every empty chamber participates in a grand equilibrium. Gravity presses downward, the stone resists, and in that balance the monument lives. Over ages sand has buried and uncovered it, earthquakes have shaken it, empires have risen and fallen around it, yet it remains fixed, unmoved, the still heart of human civilization. That endurance is its power. The pyramid's perfection is not accidental. Its base is aligned to true north with an accuracy that modern instruments only recently confirmed, within a fraction of a degree. Its faces are oriented almost exactly to the cardinal directions, a feat requiring astronomical observation and precise surveying. The ancient builders achieved this without telescopes, compasses, or lasers, relying instead on the movements of the stars and the rising sun. By embedding cosmic order into their architecture, they made the pyramid a physical manifestation of the heavens. Its geometry resonates not with electricity, but with the patterns of the universe itself. Some have called the pyramid a machine, others a temple. In truth, it is both, but its mechanism is harmony. It converts chaos into order, entropy into permanence. The very act of construction, millions of stones laid in precise sequence, transformed randomness into pattern. It is this transformation that generates the sense of energy people feel in its presence. When we stand before it, we are not sensing hidden electromagnetism or ancient engines. We are experiencing the human mind reflected back at us through geometry perfected by will. The pyramid is a mirror of consciousness made solid. Inside, the same logic prevails. The chambers, shafts, and voids form a complex interplay of mass and emptiness, creating a resonance that is as much psychological as physical. The king's chamber, with its polished granite walls, amplifies sound to create an almost supernatural echo. A whisper becomes a chord, and footsteps become thunder. The air itself vibrates with a deep, steady hum that seems to connect the listener to the weight of the entire structure. No motor, no current, no chemical reaction could produce such an effect. It is architecture as instrument, physics as ritual. To the ancient Egyptians, such effects were not mere curiosities. They believed sound was creation itself, the spoken word of the gods that brought the world into being. The pyramid's resonance, therefore, was sacred. It turned physics into theology, engineering into prayer. The builders did not separate science from spirit. They saw both as expressions of the same truth. To build a structure that could endure forever was to imitate the cosmos, to align with eternity. In that sense, the pyramid's energy is divine, not in myth, but in method. It embodies the principle that form and function are inseparable when guided by cosmic order. Recent muon and infrared studies only deepen this understanding. They show us a monument alive with gradients and voids, not a solid block, but a balanced organism of matter and absence. These hidden structures act as lungs and arteries, regulating pressure and temperature, preserving the whole through equilibrium. The pyramid's power is not static, it is dynamic stability, an architecture of flow frozen in time. It demonstrates mastery over not just stone, but over nature itself. The builders did not fight gravity, they collaborated with it. They did not defy entropy, they delayed it through balance so perfect that even decay must move in harmony. When we ask what powers the pyramids, we are really asking what principle allows them to endure when all else falls away. The answer lies not in hidden chambers or alien technology, but in a deep, human understanding of order. The pyramid's builders knew that strength arises from proportion, that durability is the child of balance, that permanence is born when chaos is disciplined by design. They created not a generator, but a lesson carved in limestone, the first and greatest equation ever solved in architecture. In this light, the pyramid becomes a kind of battery, but not one that stores electricity. It stores meaning. Every civilization that has looked upon it has drawn from it a charge of inspiration. It fuels curiosity, reverence and wonder, the most renewable energies of all. Scientists are still drawn to it because it promises the one thing science itself desires most: understanding. Each new scan, each particle passing through its ancient heart, is part of that same exchange of energy between human intellect and the silent precision of the stones. The power of the pyramid is thus not hidden in machinery but in mastery. It is the triumph of geometry over gravity, of human intention over raw material, of mind over the mute resistance of the earth. The builders achieved something modern civilization often forgets: that progress is not measured by complexity, but by harmony. They did not need wires, engines, or reactors. They needed only proportion, patience, and purpose. If the Great Pyramid holds any secret, it is this: that energy and order are the same thing seen from different perspectives. The more perfect the order, the more powerful the result. In physics, this principle governs the atom and the galaxy alike. In architecture, it governs endurance. The pyramid stands as the visible intersection of these truths, a universal constant translated into stone. And so, the mystery resolves into revelation. The pyramid is powered not by hidden forces, but by understanding itself. Its energy is the synthesis of mathematics, labor, and faith. It radiates no light and hums with no current, yet it generates the most enduring power known to humankind, the ability to inspire across ages. To stand before it is to feel that power, not as a pulse or vibration, but as a silence so complete that it commands awe. Perhaps that was the builders' ultimate intent. They did not seek to conceal a secret engine. They sought to build eternity. The pyramid endures because it expresses the laws that govern all things, from atoms to stars: balance, symmetry, proportion, and purpose. Its power is not lost. It is simply hidden in plain sight, encoded in every angle and every stone. The final truth, then, is simple yet infinite. The Great Pyramid does not run on electricity, nor on the energy of the sun, nor on mysterious cosmic rays. It runs on alignment between human intellect and natural law, between ambition and understanding, between the fleeting and the eternal. Its true engine is harmony itself. The more we study it, the more it teaches us that real power is not the act of domination, but of balance. The power of the pyramids is not a secret to be uncovered, but a principle to be remembered. It is the union of physics and faith, of stone and silence, of humanity and the cosmos. Every scan, every discovery, every whisper of data from the depths of its ancient heart brings us closer to the same realization: that the greatest energy in the universe is the will to create in accordance with truth, and the Great Pyramid of Giza is that will made eternal, still humming its silent song of equilibrium under the timeless desert sun.